Linux market has expanded rapidly in the past few years, and it is one of the top 10 occurring IT job requirements. Multinational companies such as Google, IBM, Twitter, LinkedIn are using Linux on a daily basis across various industries. Hence, if you're someone looking forward to learning Linux, then it is definitely the golden time for you. Hi all, I welcome you to this full course by Edureka, and today we're going to talk about one of the most sought after operating systems, Linux. And what follows is hopefully everything you need to know to get started with Linux. But before we begin, let's take a look at our agenda for today. First of all, we're going to start by Linux fundamentals, where we'll discuss about why go for Linux and what is Linux. We will also talk about various distributions of Linux, different shells in Linux. Next, we will be moving to Linux versus Windows versus Unix, where we will discuss about the differences between Linux, Windows, and Unix. Followed by which we will talk about Linux commands, where we will discuss the basic Linux commands, also the Linux commands for DevOps. Moving on, we will learn about user administration in Linux, where you will learn how to create user logins and manage permissions for files and directories. In the fifth module, we will talk about package management in Linux, where you will get an overview of Red Hat Package Manager, YUM, and how to install packages. Finally, we will end the session with the Linux interview questions, where we'll discuss top Linux interview questions which will help you ace your interviews. With this, I come to the end of my agenda. Also, kindly take up some time to go ahead and subscribe to us, and do not forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to learn more about Linux, do not forget to check out our certification training, the link to which is given in the description box below. So without much ado, let's get started.
Why did Linux become popular? Well, before I talk about why they became popular, let's look at the birth of Linux, how things started off. Okay, so back in 1969, there was this person called in fact there were two people, Dennis Ritchie and Ken Thompson, right? So they were working in the AT&T Bell Labs, and what they did was they created this C programming, right? So we're all aware of programming, right? So we're all aware of these basic programming languages, right? So C is one of the most basic and one of the most effective and the root of all the other programming languages. So that was C, and it was them that developed C and the Unix operating system. So that was what happened in 1969, okay? And then in the decade that followed, okay, so basically in the 1970s, people started developing or contributing to the development of these two things, okay? So they started contributing to the development of the C programming language and the Unix operating system. So in our session, we'll discuss more on Unix operating system, and since it's about Linux, right? So Unix is basically the mother of Linux, because Linux is based on the Unix operating system. Okay, I'll tell you how that's the case in some more time, but that's why we are starting off with Unix operating system. Okay, so I'm now going to cover about C, and getting back to our slides. So it says growth of Unix because of open source collaboration, and there was commercial sale of Unix. Now, what this meant is that, the product that Dennis Ritchie and Ken Thompson created, right, that those were, something really attractive. There were some amazing software and operating systems that would, power machines and computers. Now, what this meant was, they had to be developed to become even better, right? So they made it open source. It was, when we say open source, it means that it was freely available to use by anyone. So anybody, any person, any scientist, or any engineer, or anybody could just get access to the source code and start improving that source code. And if they feel that they have improved the software in any way, then they can just, give that code back to the developers. So basically, it was all about collaborated development. So that's what happened with Unix operating systems. In the 70s, many hippies, scientists, they all collaborated together, wrote their own code, their own version of Unix operating system, and contributed to the development of Unix operating system. And since AT&T, they were the ones who built Unix, or the ones they were responsible for founding Unix. They were the ones that gained a lot of benefit. They got help from other people for developing the operating system, and what they did in turn was they made it a business, right? So they made money out of that by starting commercial sale of Unix, and this was something that did not go down well with many people. And this did not go down well with the other developers and scientists, because it was their effort which contributed to the growth of Unix. But however, they are not getting any benefits of Unix, because AT&T that was making money out of somebody else's work. So that's what happened in the 1970s. Okay, and then came the 1980s, which was a little more different. So instead of buying Unix from AT&T and having two different versions of Unix, One was a FreeBSD and the other one was the paid AT&T version of Unix. So instead of going to go for them, companies started developing their own Unix. So IBM came up with their own Unix version called the AIX. Solaris came up with their own version called the Sun operating system, and HP came up with their own version of Unix called HP UX. So there are other versions also like POSIX and all these things. Now, since there were many versions, right, many flavors and many dialects of the same Unix operating system, it was becoming a little problematic because each of the dialects would be a little different. So the IBM's Unix would be different from HP's Unix and Solaris's Unix, or it would be different from POSIX. Okay, so each of them would be different, but however, they're all based on the same thing. So it was unnecessary, confusion there with so many versions of Unix. So that is when this person called Richard Stallman came up with something called as the GNU project. Okay, so I told you earlier that Linux is just a kernel and not an operating system on its own. So what this person did was, he came up with something called as a free software movement. So he wanted something like, back in the 70s when everyone could collaborate and work on the same one single operating system. Like that, he tried to bring back that era. And this free software movement of his, this idea led to the GNU project. So the GNU project was all about people being able to access an operating system for free and, developing that operating system. So that's what this led to. And that's what we call even today, right? So GNU is basically the operating system, and the Linux is the kernel that powers the operating system. So a combination of these two is what results in one of the distributions of Linux. So we have multiple distributions like Ubuntu, CentOS, Red Hat, Debian, Fedora, all these things. So all these things are flavors, a combination of one of the operating systems and the Linux kernel. Okay, so that's what they are. So this is what happened in the 1980s. And then, mid to late 1980s was when Richard Stallman came into the picture, and he came up with the GNU project where people could develop, and use free operating system. So that's what happened here. And the event that happened after this is what is a result of today's world. Okay, so after that, then in the 1990s, so probably 1991 or 1992, that was when this person called Linus Torvalds, who was still back in college at that time, he put the Linux kernel source code online. So he was trying to use the POSIX version with one hardware called 386, and he thought that it's compatible only with that hardware, and so he put the source code online for anyone to use. And later they found out that it could be used with the GNU, and that's when the whole thing gained popularity. So that's when we came up with something called as the Linux plus GNU, this whole term of having a kernel plus this operating system and getting them to work together. So that's what happened here. All right. So guys, that's how Linux was born. Okay. Now, without wasting any more time, let me go to the next slide and talk about the various distributions of Linux. So I told you that there are many versions like Ubuntu, CentOS, and also let's talk about those. And when we talk about distributions, the most important and the most famous ones are those of Red Hat Enterprise Linux, Fedora, and Debian. Okay, so these three are primarily different companies and enterprises. Well, Debian is basically not one company. It's kind of, let's say a group of developers developing this version of Linux. Okay, this version of Linux and the Ubuntu version. So that is what Debian is. And the Red Hat is basically an enterprise. It's a company that is commercially selling the Linux distribution. Okay, and it's probably the most used and the most popular of them all. Why? Because they are very stable, they are very reliable, and as it's written here, servers and workstations, right? So it's the preferred Linux distribution for servers and workstations, the Red Hat Enterprise Linux. So they have a free version, so that's called the CentOS. And today's demonstration, I'll be showing it to you on CentOS only. Okay. So they have that, and they have various other distributions. In fact, even Fedora, right, that which we are going to talk about next, even Fedora is a company that's funded by Red Hat itself. So it's again one of the variations of Red Hat, and Fedora has its own set of distributions under it, and that's about the Fedora distribution. Then comes the Debian. So this again I spoke about Debian. So Debian is the Linux distribution that is developed with the help of many developers. So this is not developed for commercial purpose. It's basically free and open source software, and anybody with the skills can start contributing to this software. And you have many other distributions, okay? So these are among the important and the commercial ones. And if you're talking about some of the free distributions which people can use, then they are Ubuntu, Linux Mint, CentOS, OpenSUSE, Gentoo, and many more. Okay, so there are almost 100 Linux distributions today, and you can use any of them. If you're getting started with Linux, then I would suggest you to either start off with Ubuntu or CentOS, because CentOS is something that's really reliable and that's really fast. Okay, and Ubuntu is the most popular Linux distribution out there. Okay, and so I read somewhere that Ubuntu is the third most used operating system. Okay, so that's what Ubuntu is all about. Of course, it's not as fast as CentOS, but still Ubuntu is a very popular and very handy tool. And Linux Mint is the other distribution which can be used for playing movies and listening to music, because this gives you more of a Windows-like interface. So that's what Linux Mint is. So we have various distributions like this. You can start off with one of these distributions mentioned here. You can either go for the Red Hat Enterprise Linux, or the Fedora, or the Debian, or the other operating systems which are based on them. Okay, so the CentOS here, it is based on Red Hat Enterprise Linux. Okay, so the RHEL, right, we call them RHEL. So they have the free version that they provide for enterprise users is that of CentOS. And Fedora, again, for that matter of fact, they have multiple distributions under them, under their name. And Debian are the people who are the founders of Ubuntu. Okay, so Ubuntu is a distribution that is based on Debian. And since Ubuntu is so popular, there are different versions of Ubuntu itself, right? There are other distributions like Xubuntu or Edubuntu, all these things, and they are the other versions of Ubuntu. So that's about the different Linux distributions. And you guys can probably, if you're newcomers, then I would suggest you to go for either Ubuntu or CentOS, like I said earlier. Okay, so now we are in this slide, and let's talk about the features of Linux here. Okay, so the Linux features, when we say features, it's basically those compared to the other operating systems, compared to Windows and compared to Mac. Okay, so compared to them, how does Linux perform, and what are the benefits with Linux? And first of all, we have this feature of the updates being very easy to be performed. If you have any software in your operating system, or if it's the operating system itself which you want to update, then it's really easy with Linux. It's just going to be one command that you need to run, and you can run that command from the terminal. Okay, for those guys who don't know what a terminal is, so let me just open my Linux version and show you what a terminal is. Okay, so this is my CentOS version of Linux. All right, and then you have different options here, right? So the terminal that you see here, this is what I was talking about. So when you open the terminal, there's another window that opens. Okay, now this is the command line interface. So when I say command line interface, this is where I can put in my commands, and I can get my software or my kernel to listen to those commands and perform actions by creating a process for those commands. So the whole benefit of Linux is this CLI, because the CLI is really helpful. If you're going for Windows or something, you have a very good GUI. All right, so even in Linux, you have a GUI. So let me show you the GUI aspect. So similar to Windows, you can just go to the computer, and you can go to file system. You can open various other folders and directories. So you have multiple directories and folders here, right? So I mean, directories are basically folders. Folders is what you call in Windows, and here you call them directories. So I can go into any of these directories, and I can close them like this. I can access any of these directories. I can access any software or anything that's installed anywhere. So Linux basically provides a GUI too. Okay, but the thing with Linux is that you also have a terminal, right? This terminal is basically a command line interface where you can put in your commands, and you can get the software to behave the way you want to. You can run certain commands, you can install software, you can run programs, you can run codes. So that's what the advantage with the CLI is. And this is basically the reason why it's very popular among all these software developers. Okay, so I told you earlier that software developers is a favorite tool, right? Linux. So that's because Linux is the free version of Unix, and it's also possible to develop and create so many programs. So that's the thing with Linux. So that's why it's so popular. So back in the slides, I told you that it was very easy to perform updates, right? So those updates can be easily performed by just running a few commands here. By writing one single command, I can update a particular software. Supposing I have Java installed in my system, then I can just write a command for updating that. I can just say sudo yum update and the package name. If it's Java, I can just put the Java version. If it's any other language, or if it's any other software, then I can put that software name over here and update the application. So that's how simple and that's how easy it is to update softwares over here. So I was talking about this aspect. So let me go back to the slides and talk about the other features. Okay, so that was how updates can be easily performed. And then another feature is that the software is free. You don't have to pay for Linux. So because Windows, of course, you all know that Windows is paid. You can't, have a pirated version. If you're caught having a pirated version, you will be fined. Of course, home desktop users and home users don't really have that problem because there are no routine checks. But companies cannot use the pirated version of Windows, because if there are audits, they can come and seize the computers and put a heavy fine on the company. So that's what we say when the free software licensing is there in Linux, because you don't have to have any license. You can just get all the folks in your company to work on Linux for free. So that's the free software licensing aspect. And then you have the access to source code, right? So when we say access to source code, I told you that back in the 70s, people could just collaborate together and develop the operating system. So that is what I'm talking about here. So the source code for running this OS, basically the Ubuntu or the CentOS source code is available to you, and you can customize it, and you can change it the way you want. You can make it behave the way you want to. And if it's a really good feature that you've added, then you can also share your discoveries and your features with other people, with other fellow developers. You can do all these things. So you have complete access to the source code, and you have complete freedom with what your OS can do and how it behaves. But the same thing cannot be said for Windows, right? So Windows, you cannot change it completely. You don't get access to the source code at all, and you can't change all the features the way you want to, because that's a proprietary tool, and it's programmed to behave in one way. And if you try changing too many things, then your Windows will report. So that's what is going to happen. So that's about the access to source code feature. And then we have another feature that is multiple distributions. So I spoke about the different distributions in the previous slide. So the basic distributions are those of Red Hat, Debian, or Fedora, right? So you have various versions of them itself. You have different flavors in the Red Hat, and you have different ones in the Debian, and again Fedora has a lot of other distributions. Further, many distributions are based on them. So you have so many options, and if you don't like one of the distributions, then you can work on another distribution, right? So if you don't like CentOS because you don't get support for everything, then you can use Ubuntu. Okay, it is the most popular operating system, and it has support for almost every application and every software, so you can use that. But if you're unhappy with the speed of Ubuntu, then you can probably switch to CentOS. So you have all that flexibility, and all this flexibility without any cost. Okay, no cost with respect to energy or having to learn something new, because all these are Linux. At the end of the day, the commands will be the same. Almost 98% of commands will be the same. There are just going to be minor differences in the commands that will be executed in the different distributions. But yeah, 98% of them would be the same. You won't have a tough transition time also. You'll have you can gain so many benefits by using Linux. And the last but not the least, right? So this feature is probably the highlight of Linux. So it says better malware protection. So when we say better malware protection, we say that it's the ultimate. Okay, in Windows, if you people would have noticed that you need an antivirus, because it's prone to viruses and attacks and bugs and all these things. So people can easily hack into your system, right? So the same thing cannot happen with Linux. You don't need an antivirus at all. Linux is completely antivirus free. Okay, 100%. You don't need an antivirus, and in fact, you don't even have an antivirus. But of course, it doesn't mean that it's completely secure. Also, security is something that's really good, but it's still developing in Linux. But it's definitely better than Windows, right? So you can be sure that no one's going to hack your system so easily. So that's what Linux is all about. So guys, that brings us to the end of this slide of Linux features.
Shells are like brands. Everybody has a favorite and vehemently defends their choice. And occasionally they might tell you why you should switch. True that shells can offer different capabilities, but they all implement core ideas that were developed decades ago. So before I begin, let me take you through the topics that I'm going to cover today. First of all, I'm going to talk a little bit about the kernel and the shell, why there might be a confusion between both of them for most people. Then I'm going to spend some time talking about the evolution of the Linux shells, various different shells. Then we're going to talk about a very common confusion, shell versus bash. Are they the same thing? Are they different? How different are they? Then come the meat and potatoes of this video. So shell versus bash versus other Linux shells. And finally, we'll spend some time talking about which shell is most apt for you. Obviously, in the end, it is your choice. I'm only here to help. So without much ado, let's get straight into the module. So first of all, the kernel and the shell. So let's talk a little bit about the kernel and the shell. So what is a kernel? Now, the computer programs that allocate the system resources and coordinate all the details of the computer's internals is basically known as the kernel. Now, the kernel is the heart of any operating system. It interacts with the hardware and most of the tasks like memory management, task scheduling, and file management. Now, users communicate with the kernel through a program called the shell. The shell is that utility that processes your requests. When you type in a command, basically at your terminal, the shell interprets the command and calls the program that you want. The shell uses standard syntax for all commands. It is basically a command line interpreter which translates commands entered by the user and converts them into a language that is understood by the kernel. And obviously, the next logical question is, what is a shell script? Since I spoke about the shell, it is only obvious that I'm going to mention the shell script. The basic concept of a shell script is a list of commands which are listed in order of execution. With that, let's move on to our next topic, which is evolution of the shell. So let's begin with a short history of the modern shells and then explore some of the useful and exotic shells that are available in Linux today. Alright? So the shell or the command line interpreter have a long history, but this discussion begins with the first ever Unix shell. Ken Thompson of Bell Labs discovered the first shell for the Unix called the V6 in 1971. Now, similar to its predecessor, this shell was an independent user program that could be executed outside the kernel. Now, I'm not going to talk about the Thompson shell. We are going to begin our journey with a look at the modern shells since 1977, when the Bourne shell was introduced. Now, the Bourne shell, created by Stephen Bourne at the AT&T Bell Labs, remains useful even today. The author developed the Bourne shell after working on an Algol 68 compiler, so you'll find its grammar more similar to the algorithmic language than other shells. Now, the source code itself, although developed in C, even made use of macros to give it the Algol 68 flavor. Now, the Bourne shell had two primary goals: to serve as a command line interpreter to interactively execute commands for the operating system and for scripting. In addition to replacing the Thompson shell, the Bourne shell offered several advantages over its predecessors. Now, the Bourne introduced control flows, loops, and variables into scripts, providing a more functional language to interact with the operating system. Now, the shell also permitted you to use shell scripts as filters, providing integrated support for handling signals, but lacked the ability to define functions. Finally, it incorporated a number of features that we use today, including command substitution and here documents to embed preserved string literals within a script. Now, the Bourne shell was not only an important step forward, but also an anchor for numerous derivatives, many of which are used today in typical Linux systems. Next, we have the C shell, which came in 1978. It was created by Bill Joy while he was still a graduate student. It has been widely distributed beginning with the 2BSD release of Berkeley's software distribution. The C shell is a command processor typically run in a text window, allowing the user to type commands. Now, the C shell can also read commands from a file called a script. Like all Linux shells, it supports file name, wildcarding, piping, here documents, command substitution, variables, and control structures for condition testing. What differentiated the C shell from others, especially in the 1980s, were its interactive features and overall style. Its new features made it easier and faster to use. The overall style of the language looked more like C programming language and was seen as more readable. Now, another improvement that we saw on the Bourne shell was the Korn shell in 1983. It was developed by David Korn of Bell Labs again as a comprehensive combined version of other major shells that were present at that time. The initial development was based on the Bourne shell source code. Now, the Korn shell is backward compatible with the Bourne shell and includes many features of the C shell as well. Now, the Korn shell compiles with POSIX2, shell, and utilities. Major differences between the Korn shell and the traditional Bourne shell include job control, command aliasing, and command history that is designed after the corresponding C shell features. After the Korn shell, we have the 10x C shell, which was a derivative of your basic C shell. Now this shell in 1983 was essentially the C shell, but with programmable command line completion, command line editing, and a few other features. Then we have Bash, which still remains one of the most popular shells even in today's time. Now this was written by Brian Fox for the GNU project as a free software replacement for the Bourne shell. It had been distributed widely as default login shell for most Linux distributions and Apple's Mac OS. Now the bash can also read and execute commands from a file. Like all Linux and Unix shells, it supports file name globbing, piping, here documents, and command substitution. The keywords, syntax, and other basic features of the language are all from the basic shell. The shell's name is an acronym for Born Again shell, a pun on the name of the Bourne shell that it replaces. The bash command syntax is a superset of the Bourne shell command syntax. It supports brace expansion, command line completion, basic debugging, and exception handling using trap. Now it can execute the vast majority of shell scripts without modification, with the exception of the Bourne shell scripts stumbling into fringe syntax behavior. The bash command syntax includes ideas drawn from the Corn shell and the C shell as well. After that, the world came across various other shells such as the public domain Corn shell, which was basically a public domain or a free version of the Corn shell. You had the Alchemist shell, then you had the Extensible shell or the Plan 9 shell. Today we have many other shells, namely your Z shell, your Debian Armquist shell or the Dash shell, and the MirBSD Corn shell. In this segment, I am going to majorly focus on 4 shells, which will give you an idea of all the other derivative shells as well. I'm going to be talking about first the basic shell, the Bourne shell. I'm going to talk about the Born Again shell, the Corn shell, the 10xC shell, and an exotic shell called the Scheme shell. Moving on, let's talk a little bit about shell versus bash. Now, most people use these two terms synonymously, but they are not the same thing. Now, the shell command language is a programming language which is described by the POSIX standard. It has many implementations, including the bash. Now, because shell is a specification and not an implementation, the /bin/sh is a symlink or a hard link to an actual implementation on most of the POSIX systems. Now, the bash started as a shell-compatible implementation, but as time passed, it has acquired many extensions. Now, many of these extensions may change the behavior of valid POSIX shell scripts. So, by itself, bash is not a POSIX shell. Rather, it is a dialect of the POSIX shell. So, summarizing about this, I would say that shell is actually a specification of which bash is an implementation. For a long time, the shebang line of the shell script used to point to the bash on most Linux systems. As a result, it has become more safe to ignore the difference between the two. But both of them are pretty much different things. With that, let's look at shell versus bash versus a few other Linux shells. First of all, the C shell. Now, if you're a network or systems administrator in a Linux or Unix environment, you will most certainly run into the C shell. So it is good to at least have some familiarity with it. Now, casual users and even most developers will probably suggest other shells, but if you are comfortable with C programming language, then the C shell is a great shell to begin with. Now, the Corn shell is the one that you can use interactively to execute commands from the command line or programmatically to create scripts that can automate many computer maintenance and system administration tasks. Now, bash is far too big a subject to be covered fully in a single line, but it is one of the most commonly used scripting languages that you will find today. People are comfortable with bash scripting, and most of the content that you will find around shell scripting will be in bash. But you should probably learn it for its versatility and ease of use more than anything. Most colleges and universities teach their students to script in bash because it's a great place to begin as well. So now I'm going to run the same script in 3 different shells, which are derivatives of the 3 most basic shells, which are your Bourne shell, your C shell, and your Korn shell, to see how different or similar they are. So for that, I have opened up my terminal. This is CentOS 7, the Fedora version. So what I'm going to try to do is take a single argument, which is going to be a directory name, and my script is supposed to search recursively for all executable files in that directory along with the number of files that are found. I'm going to reuse this script design in each of the examples to illustrate the differences. So first, let's see what directories do we have. Okay, so what I'm interested in is this Eclipse directory. So what I'm gonna do is, okay, this is one file, Java Oxygen. Let's see if it's executable or not. Okay, as we see, the Java Oxygen file is executable. So when I pass Eclipse as an argument, this directory as an argument to any of my scripts, I am supposed to get an answer that this Java Oxygen file is executable and the number of executable files found in that particular directory is equal to 1. So first I'm going to run the 10x shell and see. So I'm going to go and open up this 10x shell. So basically what I did is open up my 10x script. It's divided into 3 basic sections. First, note that I use the shebang symbol to declare this file as interpretable by the defined shell. This allows me to execute the file as a regular executable rather than precede it with an interpreter binary. All right? It maintains a count of the executable files found. So I initialize this count with 0 here. So the first section, this section right here, tests the arguments passed by the user. This argv variable represents the number of arguments that are passed, excluding the command name itself. Now you can access these arguments by specifying their index. For example, if I say this #1, it refers to the first argument. The script is expecting one argument. If it doesn't find it, it emits an error image. So using this $0, I'm going to indicate the command name that was typed. Now let's come to the second section. This basically ensures that the argument passed in was a directory. The D operator here, the -D operator here, returns true if the argument is a directory, but note that I specify a not directory sign here, this exclamatory symbol, which means negate. Now this way the expression says that if an argument is not a directory, you emit an error message, which is this one. And for the final section, it iterates the files in the directory to test whether they are executable. I use the convenient for each iterator, which loops through each entry in the parentheses, in this case which is the directory, and then tests each as a part of the loop. Now this step here uses the -x operator to test whether the file is an executable. If it is, the file is emitted and the count is increased. I end the script by emitting the count of executables here. Okay, so now that we have understood what the script is, let's go ahead and run this. And then I'm going to try Eclipse. And as we had predicted, it says that Java Oxygen is your executable file and 1 executable files found. Now let me clear this out for you. Next, let's try doing the same thing with our Korn shell. Now this is the code. Now as you can see, our shebang line, immediately it's different. Now this Korn shell is a derivative of the Bourne shell and it looks so much more similar to it than the C shell. So let's look at our example again. Now the first thing you'll notice here is its similarity to the first code that I had put up. Let me open it side by side for you. Okay, so what I'm going to do is I am going to open another new terminal. Let me just open another tab right here, another new window, so I can basically show you the similarity between both of these. So I'm going to go ahead and okay, now we have these two on both sides. So the first thing you'll notice on your corn shell script is its similarity to the 10x shell script. Structurally, the script is almost identical. The first, second, and third parts of the script, you have your test arguments, then you have your ensure argument, which is a directory, and then you iterate the directory to emit the executable files. But the key differences are evident in the way conditionals, expressions, and the iteration is performed. For example, instead of operating C-like test operators, the case adopts the typical bond style operators. So here you can see this not equal to versus here this not equal to. Now the corn shell also has some differences related to the iteration. Now in the corn shell, the for in structure is used with the command substitution to represent the list of files created from the standard output of the command ls, representing the contents of the name subdirectory. In addition to the other features defined here, the corn supports the alias feature to replace a word with the user-defined string. Now the corn has many other features that are disabled by default, such as file name completion, but you can enable it if you want to. So let me close this. So let's try running this file and let's put in Eclipse again. And as you see, the answer is the same. Okay, finally, we are going to try the same thing using the bash or the born again shell. Now the bash has continued to evolve with new features, support for regular expressions, and associative arrays. Now, although some of these features may not be present in other scripting languages, it's possible to write scripts that are compatible with other languages. To this point, this script that you see here is identical to the corn shell script, except for the shebang difference. Let me open the corn shell real quick and give you a side-by-side comparison on this. Okay, so as you can see, it's pretty much the same except for your shebang line, which obviously has to be different because of where they are pointing. One key difference among these shells is the licenses under which they are released. Now the bash, as you would expect, having been developed by the GNU project, is released under GPL. But the C shell, 10x C shell, Z shell, and so on are released under BSD in BSD-like license. The corn shell is available under the common public license. But apart from that, as you can see, the way you write the script in bash and corn is the same except for their shebang line. So let me just run this and show it to you. And as you can see, the answer is the same. Now my point being why I chose these three specific shells is that it'll give you an idea of how all the other derivative shells work. More or less, it's going to be similar to these three basic shells. Else your logic will always remain the same. With that, let me move back to my presentation. Now, apart from these, you can go ahead and pick the shell you like. Many of the ideas and much of the interfaces of the shells remain the same almost 35 years later, a tremendous testament to the original authors of the early shells. Now, in an industry that continuously reinvents itself, the shell has been improved upon but not substantially changed. Although there have been attempts to create specialized shells, customized shells, the Bourne shell derivatives continue to be the primary shells in use. Linux versus Windows is an age-old battle of the operating systems. It has caused many flame wars, disagreements, and almost fanatical behavior on internet forums and blogs for what seems like forever. I think it is important to stress that this session will discuss not which OS is best, because it is impossible to come to that conclusion, and subjective opinion will never be correct to anyone who isn't that person holding the belief. There are also some age-old cliches about these respective systems that has served no one till date. We're going to start out with what is Windows, where did they come from, why do we need them, and what are their specialities, features. Then we're going to discuss a little bit about the history of these OSs. Then we are going to go to the main part of this session, which is Linux versus Windows, a toe-to-toe comparison of these two OSs. Then we are going to discuss the distributions, talk a little bit about the latest distributions. Finally, I'm going to discuss which operating system is most suitable for which user. So without much ado, let's get started. Windows is a licensed operating system which has the source code as inaccessible. It is designed for individuals with a perspective of having no computer programming knowledge and for business and other commercial users. It is very simple and straightforward to use. It is extensible, portable, and assists multiple operating environments, symmetric multiprocessing, and client-server computing. It offers integrated caching, virtual memory, and preemptive scheduling. Now, Windows 10 is the latest release of Microsoft Windows operating system. Its default user interface is a Windows shell, and it uses hybrid kernel in the older versions and the microkernel in the newer version. Now, Windows is a series of operating systems developed by Microsoft for personal computers, desktop devices, and a few mobile phones. Each operating system comes with a graphical user interface with the desktop, which allows a user to view all files, videos, etc. The first version of the OS was released in '85, which is a simple GUI, an extension of the disk operating system or MS-DOS, and the major release, as of my point of view, was in 1995, the consumer release which integrated Windows and DOS with built-in internet support. Now the latest Windows OS version is the Windows 10, which is currently ruling the market. Next, let's look at a little bit of history on the two. Now the first version of Windows, known as Windows 1.0, was revealed in 1985 following the formation of Microsoft. It was based upon the MS-DOS core and at that time the most widely used program manager for running applications. Following the initial launch, the new versions of Windows were quickly rolled out, including the first major update in 1987, quickly followed by Windows 3 in the same year. The journey of the evolution happened quickly, and in 1995, perhaps the most widely used version yet, Windows 95 was born. Don't you all remember those days? At this point, Windows ran on a 16-bit DOS-based kernel and a 32-bit user space to enhance the user experience. Can you think of this? 32 bits of user space. We have more than that in our cell phones now. But getting back to the point, Windows hasn't changed a lot in terms of core architecture since '95. And although the vast amounts of features have been added onto the address of modern computing, many of the elements we recognize today were ever present. For example, the Start menu, the taskbar, and the Windows Explorer, which is now called as the File Explorer, all presented themselves in Windows 98. Linux was launched much later than Windows, in 1991. It was created by this Finnish engineering student, Linus Torvalds, who wanted to create a free operating system kernel that anybody could use. Although it still was regarded as a very bare bones operating system without a graphical interface like Windows, it nevertheless grew considerably within just a few years. With a few lines of source code in its original release to where it stands today, containing more than 23.3 million lines of source code, Linux was first distributed under the GNU General Public License in 1992. With that, let's move on to Linux versus Windows. This might be the reason most of you are still hooked onto this session. So let's start up with users. Now, there are three types of users in Linux. You have regular, administrative, and service. Now, a regular user account is created for you when you install Ubuntu on the system. All your files, folders are stored in /home/, which is your home directory. And as a regular user, you do not have access to directories of other users. Next, you have the root user or the administrative user. Other than your regular account, another user account is called root, and it is created at the time of installation. The root account is a super user account who can access restricted files, install software, and have administrative privileges, hence the name administrative user. Whenever you want to install software, make changes to the system files, or perform any administrative task on Linux, you need to log in as a root user. Otherwise, for general tasks like playing music and browsing the internet, you can use your regular account. And the third and final account is the service user. Linux is widely used as a server operating system, and services such as Apache, Squid, email, etc. have their own individual service accounts. Having a service account increases the security of your computer. Now, Linux can allow or deny access to various resources depending on the service. Now, in Windows, there are 4 types of user accounts. You have your administrative, standard, child, and guest account. Next, let's go ahead and look at usage. Now, according to the market research data of the September of 2007, 92% of the world's PCs had Windows running, while only about 1% of PC users used Linux. The home users, multimedia enthusiasts mainly used Windows, whereas for serious use, server application corporation servers were running on Linux. Irrespective of the GUI, many users found it difficult to use Linux as compared to Windows, obviously due to the command line interface. And so the appeal of Linux was very limited to common people. Also, for licensing agreement with Microsoft, various PC vendors are entitled to bundle Windows OS with their PC. And for this, Windows gained the initial market popularity over Linux. Though these days, many PC vendors such as Dell and HP started to give Linux as a pre-installed OS to cut the cost of their PC system. According to the latest IDC report, Windows Server market is gaining popularity over Linux-based server. The annual rate at which Linux is growing in the x86 server space has fallen from around 53% to 45% globally. The main reason is that while Linux servers are looking for high-performance computing and web serving, Windows is apparently adopted on a much broader basis. Next, let's move ahead and look at what the kernels are like. Now, Linux uses a monolithic kernel which consumes more running space, whereas Windows uses the microkernel as of the latest versions, which take less space, but the system running efficiency is lower than Linux. Next, let's look at file systems. In the Microsoft Windows, files are stored in folders on different data drives like C, D, E. But in Linux, files are ordered in a tree-like structure starting with a root directory. Now, this root directory can be considered as the start of a file system, and it further branches out various subdirectories. Now, the root is denoted with a // and a general tree-like system on your Unix may look like something like this on your screen. In Linux and Unix, everything is a file. Directories are files, files are files, and devices like printer, mouse, keyboards are also files, which is not the case in your Microsoft Windows. At number 5, we have security. Every Windows user has faced security and stability issues. Since Windows is the most widely consumed OS, hackers, spammers all target Windows very frequently. Consumer versions of Windows were originally designed for ease of use of a single user PC without a network connection and did not have the security features built in. Now, Microsoft releases security patches through its Windows Update service approximately once a month, although critical updates are made available at shorter intervals when necessary. Many times, users of Windows OS face the blue screen of death caused by the failure of the system to respond, and eventually the user has to manually restart the PC. This is super frustrating, and it also may cause you to lose valuable data. On the other hand, Linux is a very stable OS and is more secure than Windows. As Linux is community-driven, developed through people collaboration and monitored constantly by the developers from every corner of the world, any new problem raised can be solved within just a few hours, and the necessary patch will be ready at the same time. Also, Linux is based on Unix architecture, which is a multi-user OS, so it is much more stable than a single-user OS such as Windows. Next, let's look at compatibility of the two. Here, Windows shoots and scores. Here is where the Redmond offering wipes the floor with Linux. Despite recent improvements in software being ported or developed to Linux, Windows is still the king. Users of Windows can be certain that most softwares will work, and even obscure, outdated software will continue to work even when it is abandoned by developers. Windows has good legacy support, plain and simple. I know of commercial software that still relies on technologies like Silverlight, ActiveX, and Internet Explorer 11. Linux, on the other hand, can struggle with the basics that Windows users take for granted. Adobe Flash Player is something else that is missing on Linux for a really long time. And even when it did appear with repositories, it was not as actively developed as Windows versions. With regard to file systems, Linux can also read and write to NTFS and FAT formatted devices and USB sticks, whereas Windows will have no idea what extension 4 is. At number 7, we have ease of use. Now, this is a tough one to call. Linux over the recent years has made huge leaps in usability. Distributions like Linux Mint have made installation and setup pretty simple. Even non-technical users can install and use software and do normal day-to-day activities like web browsing, answering emails, playing music, and watching videos. Windows, due to high market proliferation, is the default OS of many devices. Now think of it, people like you and me, we grew up on Windows, right? Buy a new laptop or a PC, there is a very high chance that it comes with Windows installed. Users are used to clicking the toolbar, opening their favorite programs, which makes it good for power and non-power users. Next, we have privacy. Linux users have a private operating system that does not spy on them and does not phone home with any degree of seriousness. Period. Choosing Linux means the system is yours and yours alone. Add to the mix that most Linux systems come with an option of a built-in military-grade encryption, and users can be sure that the device theft poses no real problem to their own data. As a contrast, increasingly over the last few years, Windows has gotten more advert-driven. Users are given the choice to opt out, and there are some clever registry hacks that can help, but advertising is now a part of Redmond's plan. Windows can also watch what users do, offering syncing to Microsoft OneDrive service, or to learn behavior to make Cortana, the Microsoft personal assistant, better. Personally, I do not favor these kind of intrusive tools, but some users do like these features. Like, who wouldn't want a personal assistant in your laptop? You already have your Google Assistant and your Siris, right? Next, you have source code. Now, this all of you might know, Linux is open source, whereas Windows is commercial. So users have access to the source code of Linux and can alter the code as per user need, whereas Windows users do not have any access to their source code. Now, this has its own advantages in Linux, like bugs in OS will fix at a rapid pace, and disadvantages like developers may take advantage of any weakness in the OS if they are found. In Windows, every user would not have access to the source code. Only members of a selected and qualified group will have access to it. Next, you have license. Now, the Linux kernel and the GNU utilities and libraries which accompany it in most distributions are entirely free and open source. You can download and install GNU Linux without any purchase. Some companies offer paid support for their Linux distributions, but the underlying software is still free to download and install. A funny folklore here is that Linus Torvalds actually was an introvert and did not want companies to communicate with him through email. He did not want to be spammed by all these big companies running the industry to buy the source code to his kernel. So basically what he did was he made it open source for everybody to access. Funny, isn't it? Now, on the other hand, you have Microsoft Windows, which usually costs between $99 to $199 US for each licensed copy. Now, Windows 10 was originally being offered as a free upgrade to current owners of Windows 7 or 8.1 if they upgraded before the 29th of July 2016. But that offer is no longer available. Then you have reliability. Now, Windows as we know it becomes sluggish day after day. You will want to reinstall Windows after a while when you encounter crashes or slowdowns on your system. If you're using Linux, you will not have to worry about reinstalling it just to experience a faster, smoother system. Linux helps your system run smooth for a longer period of time. In fact, much longer in my experience. Also, with Windows, you will have to adapt to a habit where you keep on rebooting the system for just about everything. If you just install software, reboot. If you recently uninstalled software, reboot. If you just installed a Windows update, reboot. And if the system seems to slow down, you guessed it, reboot. However, in the case of Linux, you will not have to reboot for the situations previously mentioned. You can comfortably continue with your work and Linux will not bother you. Another fact that proves Linux to be a reliable source are the web servers. You could observe that most of the internet giants like Google and Facebook run on Linux. Even most of all the supercomputers run on Linux. So why isn't Windows preferred over Linux? It is because Linux is far more reliable than Windows. Period. No arguments. Finally, we have support. Now, Windows has a support which is easily accessible, online forums or websites, and it has paid support as well. In a Linux system, you need not hire an expert to solve a problem. You just need to search for a familiar thread on the web for a solution or post a thread to let others know of the problem. Within minutes of posting the thread on any Linux forum, you may expect a reply along with a detailed solution which would finally help resolve your problem at no cost. It's like Linux has its own Stack Overflow community, doesn't it? Now, there are a lot of active Linux users who are always ready to respond to a relevant thread that might have created. The number of community users active on such forums is more than the number of active members on any Windows-focused forum any day. However, the community response might be depending on the Linux distribution being used. With that, I come to the end of my Linux versus Windows segment. The last category is distributions. Now, before we begin, I need to address one of the more confusing aspects to the Linux platform. While Windows has maintained a fairly standard version structure with updates and versions split into tiers, Linux is far more complex. Originally designed by the Finnish student Linus Torvalds, the Linux kernel today underpins all Linux OSs. However, as it remains open source, the system can be tweaked and modified by anyone for their own purposes. What we have as a result are hundreds of bespoke Linux-based operating systems known as distributions or distros. This makes it incredibly difficult to choose between them, far more complicated than simply picking Windows 7, Windows 8, or Windows 10. Given the nature of open source software, these distros can vary wildly in functionality and sophistication, and many are constantly evolving. The choice can seem overwhelming, and particularly the differences between them aren't always immediately obvious. On the other hand, this also has its own benefits. The variety of different Linux distros is so great that you can all find something that suits your particular taste. Do you prefer a Mac OS style interface? You're in luck. Elementary OS is a Linux distro built to mirror the look and feel of an Apple interface. Similarly, if you yearn for the days of Windows XP, you can bring that back with a Q4 OS, which darkens back to the Microsoft's fan favorite. Now, there are more specialized Linux flavors, such as distros designed to give ancient, low-powered computers a new lease of life, or super secure distros that can be booted from a USB drive to keep you safe when using an unfamiliar PC. Naturally, there are also numerous Linux versions for running servers and enterprise-grade applications. For those who are new to Linux, I'd like to recommend Ubuntu as a great starting point. It is very user-friendly even compared to Windows, while still being versatile and feature-rich enough to satisfy experienced techies. It is the closest thing Linux has to a default distro, although we would urge everyone to come and explore various distribution options available and find out what is your favorite. Next, let's look at which OS is most suitable for you. Now, this one depends on what you need to do. Both Linux and Windows are rich in multimedia applications, though setting up sound and video options in the older versions of Linux can be difficult for some users. The main advantage of Linux is that most of the multimedia applications are freely available, while in the case of Windows, users might have to pay a hefty amount to get the software, although many open source free versions are often available. Moreover, if anybody buys a copy of Windows on a CD-ROM, they do not get any application software with it, other than the bundled Microsoft software. But if the same person buys a copy of a Linux, it typically comes with a lot of free application software such as OpenOffice, a complete free Office suite, including spreadsheets, presentations, so on and so forth. A new computer with Windows pre-installed may have additional application software, but that is totally up to the PC vendor. But each Linux distro comes with multiple flavors. The more expensive versions come up with more application software. If you're a gamer and need 100% compatibility with a particular software or want a user-friendly system, hands down, Windows wins. Steam, amongst other clients and options, provides a huge number of games for both AAA publishers and small indie developers. While Steam for Linux now allows you to install Windows games, it is still in beta phase. And not all Windows games will work. It can be a little frustrating for Linux users like myself, and no doubt the situation will change in the future. But as of now, in 2019, many Linux users miss out on the top games with their choice of OS. The graphics card vendors also tend to support Windows platforms rather than Linux. They provide timely updates and new features that don't always filter to other OSs. If you're an advocate of open source software, or if your device simply is too old or lower spec to run Windows, or just plain tired of all the forced updates and reboots in Windows, then Linux is a great option. Linux supports almost all major programming languages: Python, C, C++, Java, Perl, Ruby, etc. It offers a vast range of applications useful for programming purposes too. Now, the Linux terminal is superior to use over Windows command line for developers. You would find many libraries developed natively for Linux. Also, a lot of programmers point out that the package manager on Linux helps them get things done easily. Interestingly, the ability of bash scripting is one of the most compelling reasons why programmers prefer Linux OS. Linux also brings in native support for Secure Shell, which would help you manage your servers quickly. You could include things like apt-get commands, which further makes Linux one of the most popular choices for programmers. Unix versus Linux. What are the differences and what are the similarities? So what is Unix? Now, the Unix OS was born in the late 1960s at the AT&T Bell Labs. It basically began as a one-man project under the leadership of Ken Thompson and went on to become one of the most widely used operating systems. Now, it worked on command line interface, but recently there have been developments for GUI or graphical user interface on Unix systems. It is an OS which is popular in companies, universities, and big enterprises, which is commonly used in internet servers, workstations, and PCs. Now, something to notice about Unix is that it is written in C, which at that time allowed quicker modification, acceptance, and portability. It is a multi-user, multitasking operating system, which can be used as a master control program in workstations and servers. So hundreds of commercial applications are available on the Unix OS, which is why it was rapidly adopted and became the standard OS in universities in its heydays. With this, let's move on to the differences between both of these OSs. So let's look at our first basis of difference, the use. Now, Unix is mostly used in internet servers, workstations, and PCs, while Linux is used by everyone, from home users to developers and computer enthusiasts alike. Because Linux OS can be installed on various types of devices like mobile phones, tablets, and computers. Development and distribution. Now, Unix systems have different versions, and these versions are primarily developed by the AT&T as well as other commercial vendors. While Linux, as most of us know, is open source and thousands of programmers collaborate online and contribute to its development. It features through forums, etc., and is distributed by various vendors. Now, talking about the architecture, Unix is available on PA RISC and Itanium machines. Solaris is also available for x86 or x64 based systems. Now, Linux originally was developed for Intel's 86 hardware. So the ports available are for over 24 CPU types, including the ARM. Now let's talk a little bit about the processors of the two. Now Unix supports your x86, x64, Spark, Power-Itanium, PARISC, PowerPC, and many others. Whereas the Linux has a wider variety of processors that it supports, which include dozens of different kinds of processors. File system support, or the supported file type. Now Unix supports ZFS, HFX, GPS, XFS, and VXFS systems, whereas the Linux is supported by file types XFS, NFS, CRAM, FSM from 1 to 4, UFS, DevPTS, and NTFS, which again is a wider variety of file types. Next, let's talk a little bit about something both of these are very known for, that is their shell interface. Now, the Unix was originally made to work in Bourne shell, or the basic shell that we all know of. However, it is now compatible with many other softwares, whereas in Linux, Bash is the default shell. It offers supports for multiple command interpreters. Now that we've spoken about the shell interface, the next logical question is obviously about the graphical user interface. Now, the Unix has a common desktop environment and also has GNOME, whereas Linux provides two GUIs, which are the KDE and GNOME, though there are many alternatives such as Mate, XFCE, etc., which are just a few of the millions of alternatives that it has. Next, let's talk a little bit about the portability of each of these. Now, Unix is not portable, period, that's it. But Linux is portable and is booted from a USB stick, which is a big plus in the side of Linux. Now, of course, this is the next question, security, which is one of the most important features when we move to a certain OS. Now, till date, there are between 80 to 120 viruses that have been reported in Unix, whereas Linux has had about 60 to 100 viruses listed to date, which are currently not spreading. So the next most logical question is the threat detection and solution procedures. While Unix users require longer wait time to get the proper bug fixing patch, threat detection and solution is very fast in Linux because Linux is mainly community driven. So if Linux users post any kind of threat, a team of qualified developers start working to resolve this threat. Now next, let's talk a little bit about the source code. Now this must be an obvious to all of you. As we all know, the source code of Unix is not available to anyone, whereas Linux being an open source OS, the source is available to the general public. And finally, the license. This is something most of you must be waiting for. Now in Unix, different flavors have different pricing depending upon the type of vendor, whereas Linux is freely distributed, downloaded through magazines, books, websites, etc. There are priced versions for Linux as well, but they are normally cheaper than that of Windows. Now let's discuss a few limitations of each of these OSs, starting with Unix. Shall we? Now the limitations of Unix. Firstly, it has an unfriendly, terse and inconsistent and non-mnemonic user interface. Apart from that, the Unix OS is designed for a slow computer system, so you can't really expect a fast performance. Versions on various machines are slightly different in Unix, so it lacks consistency. And finally, Unix does not provide any assured hardware interrupt response time, so it does not really support real-time response time systems. Apart from this, the shell interface can be treacherous because a single typing mistake can destroy a lot of files. With that, let's move on to a few limitations that Linux possesses. So here are a few limitations in Linux. First of all, there is no standard edition of Linux. Secondly, Linux has a patchier support for drivers, which basically may result in the misfunctioning of the whole entire system. Many of the programs we are using for Windows will only run on Linux with the help of complicated emulators, for example, the Microsoft Office. And finally, Linux is really suitable for only corporate users.
it is way harder to introduce in a home setting. Linux, for new users at least, is not as easy to use as Windows. With that, let's move on to look at a few market trends on Unix and Linux. If we look at overall usage, the Unix OS is used by 69.5% of all the major websites. It's historically leading the chart. But despite that, Linux has started to expand its market rapidly since 2018, as you can see in the graph below. The ability of Linux to easily coexist along with other operating systems and its portability give it a solid edge in the market today. But in the end, the choice is yours, Linux or Unix. Both the OSs have their own pros and cons.
Let's move on to our terminal and look at the basic Linux commands. Now, for those of you who are wondering, I'm using CentOS 7, the Fedora version, and I'm running it on the Oracle VirtualBox. So before I begin with all the commands, I'm going to list down the commands that I shall be using with something known as a nano editor. So Linux commands.txt. Okay, now this is basically a text editor which has overridden the other terminal that we are using. Now what I like about the nano editor as compared to the Vim editor is that you get all these options below on your screen. So if you had to get help, all you had to do was press your caret and G simultaneously. Now this caret sign over here, not to be confused with your Shift 6, this is basically a sign for control. So what I'm going to do is I'm going to start by listing out the commands that I shall be discussing. So first of all, we have pwd, which displays the current working directory of the terminal. Pretty simple. Then we have echo, which is like Linux's version of print. We have sudo, which executes only that command with super user privileges. You'll know in a little while what I'm talking about. Then we have clear, which basically clears the screen. Nothing too rocket sciencey there. Then we have change of directory. We have ls or list. We have cat or concatenate. We have less. Both of them might seem similar to most people using it, but I assure you they are different, and you'll know just in a little bit how much. Then we have grep, which basically uses to search for a particular string or a word in a text file. Then we have sort. Pretty self-explanatory, you use it to sort. Then we come into this area where we have your move, your copy, your remove. Pretty simple, the name suggests everything. Then you have your mkdir, which basically makes directory. It creates a new directory. Then we have your rmdir, which removes a directory. And then we have chmod, which basically is used to change the access permissions of files and directories, which is a topic in itself, and that is why I have put it towards the end. So with that, let's save this text file, Control O or write out. It says we have written 16 lines. Now all I want to do is exit this editor, and I am back here. So as I had noted, the first command we're going to talk about is pwd. It basically stands for print working directory. It shows your current working directory. We are at home/edureka, and that you can see on your left also. We are at home/edureka. Then you have echo, which is basically print. So if I want to print hello learner, all I'm having to do is type echo and go ahead and do a hello learner. And it prints that out. No rocket science here. Then what else did we have? We had sudo, which you basically use to execute a command that only users with super user privileges can do. This I shall touch upon later when we come to a point where we have to use it. We have an entire section where I'm going to be using it. That is for installing packages and so on. So we'll touch upon that later. For now, let's move on to our other commands. So what I'm going to do now is I'm going to change directories. I'm going to go home. All right.
So now what we have is we have ls or list. This command basically lists all the contents of your current working directory. So these are all the contents that are there in home/Edureka. Now another thing you can do is you can go ahead and do something known as your --help. Now this might look like a lot of text right here, but what you need is somewhere up here. All right, if you go up, you will see that there are certain flags given which you can be using with these commands. And here, along with the flag, it shows you their usage or use case. So your -a basically stands for all, and it gives a short description about it. I'm going to go down. If I go down here, -Z is your context, and it will display the security context, so it fits on most displays, and it gives some of the information, a lot of information. So this you can do with every Linux command that there is. It is almost universal to all distributions of Linux. So with that, what I'm going to do is I am going to clear this out, and we're going to look at a few flags after list and see how they work. So apart from the basic ls, there you get the list of all the files and directories that are there in your home/Edureka. You can also type ls and put in a path. So if I go ahead and I'm like home, Edureka, and suppose Eclipse, you see there is one directory there called Java Oxygen. All right, let's use this flag called -l. Now this, what basically the -l did was it listed all the contents along with its owner settings, permissions, and timestamps. This is also known as the long format. So basically what this means is, suppose this is a file called q11.sh. This gives the date and time at which this was created. It gives you the username. It also gives you the user group. And then on the extreme left, if you would see, it has something written in 3 parts. So basically what these are permissions that are associated with these files. The first set of permissions is for the user. In my case, it is me. The next set of permissions is for the user group, and the final set of permissions is for others. This I'm going to talk about when I talk about chmod in just a little while. So what I'm going to do, I'm going to go down and go with the next thing in list. So another thing you can do is ls -- and author. And basically what the author flag lists is the contents in the specified directory along with your owner name. So if I go ahead and do ls author, I'm supposed to be putting in, say, Eclipse, and it says Java Oxygen, and it is created by the basic user, which is Edureka. The final flag that I'm going to talk about is ls -ls. Then I'm going to use this, and then go ahead and type file. Suppose I'm using the file that I created just a while ago. So I'm going to call it text.txt. Basically what this arrow sign did was it copied the result of the ls command into the text file called text. So let's go ahead and see what's in the text file. For that I'm using cat. And there you go. In that text file that I had created earlier, it has copied down your entire list of what was there in that particular directory. All right. So with that, we come to the end of your list options. Now we are going to go into another command called cd or change directory. Before that, let me clear the space out. We want to keep our workspace clean and tidy. So cd. Now if I put a path here, I am going to change my directory to whatever path I have mentioned. So now I've moved from Edureka to home, and in the similar way I can move from home
to Edureka. Very simple to use, I'm assuming. Also, another way to move to home would be if I typed cd and I put up this sign. And here I am at home. Now, another way I can do this is if I put a front slash, it changes the directory to the root directory, like so. Or I could just go ahead and cd and then 2 dots, puts me in parent directory, which again is the root. Now what I'm going to do is I'm going to go back to my home/Edureka. And with that, we've come to the end of all the versions of change directory that I wanted to show you guys. Let's clear this out. All right. Next, what do we have? We have cat. Now, what this command does is that it displays the content of a text file and concatenates several files into one. So let's just see what all files we have here. What is the file that I just created? So I created a file called linuxcommands.txt. If I go on and type cat, as I had done one time earlier, but this time I'm doing it to explain. So I'm going to do this, and as you can see, this was what I had put in my Linux commands. If I go ahead and open that particular nano editor, you can pretty much see the same thing. Yes? If you remember, I had mentioned something known as less. Now let's see how that's different from cat. Now, as you can see, less also opened up my Linux command.txt. The contents of it's showing to me, but it opened them in a separate window. Now, what this does is it won't affect the terminal that you're working on at all, the window that you're working on. It basically helps you keep your workspace clean. And you can just press Q to quit from there. And that is the only difference between less and cat. Now, there are many more, but this is the basic difference between less and cat. Less helps you keep your workspace a little less cluttered, while cat prints it all on the workspace that you're working on, making it more cluttered. So next, there is something known as cat-b. And then I'm going to put up the same thing, which is Linux commands. Now, basically what it did was it has added line numbers to the non-blank lines. So these are all my non-blank lines, and cat-b, the B flag, has added numbers to all these lines. Let me just go ahead and do something. If I had to go here and I want to add a few lines in between which do not have anything in them. So these are basically empty lines. I'm going to save this and quit from here. Now let's try doing the same command again. Let's try running cat with the B flag again. And you see it hasn't added numbers to the blank lines in between. But if I do the same thing with an N flag, as you can see, it has added these line numbers even to the blank lines. So basically, this is used to add line numbers to all the lines. Then you have something known as the S flag. And I'm going to use it on the same text file. Basically, what it does is it brought all those lines and made it into one line. It's used to squeeze blank lines into just one line. And there's much more that you can do with concatenate. For now, we are going to stop at these many flags. Let me clear this out again. And we are done. Next we have, let's see, the grep command. Now we use the grep command to search for a particular string or a word in a text file. So if I had to use grep, let's see, I'm going to type grep and then I'm going to go cd, which is the word, and then I'm going to type my text file's name. And since there is cd there, it found out cd. Now let me go ahead and alter this a little bit. Now that was just one word in this entire text file. Let me just go ahead and add a few more. Let me make tweaks in this text file to show you guys some demo. So let me make use of these blank lines. Go up and do cd-A, cd-B, and cd-C. Okay, so let me try the same thing again, and you'll get a better idea of this. Now you can see any element which has cd in it, we got that printed out. Doesn't just have to be a word with only the alphabet C and D. Any word or any element which has cd in it, grep is going to print that out. Now you can also add flags and use grep in different ways. For example, if you have, say, your I flag here, basically what it does is it returns the result for case insensitive strings. I'm going to go ahead and type again cd, and basically all of these are case insensitive. We have no uppercase elements over here, and there are many other ways you can use the pipe operator to pipe what's there in the left with what's there in the right. So many options that you have with this particular command. Right now the time will not permit me to show you all the flags, so let's just move on, clear the screen, make it a little better to look at. Now we have the sort command. Before I go ahead with my sort command, let me just go and clean my text editor. Let me just clean up my list so that we have an actual idea of what we are doing. All right, all set. Let's use sort. Now if I went ahead and did a sort and same thing, excuse me for using the same text file again and again and again, it's just easier. Now that I did this, as you can see, it just sorted the whole entire thing in alphabetical order. So we start with the cat and end with sudo. Now I've gotten my numbering all wrong. I'm going to depend purely on memory to make you all go through the various different commands that I was going to. Now I've just passed one argument here. You can go ahead and pass many more. It can take n number of arguments. You can just go on giving spaces in between, putting argument after argument. Your sort command will work. Also, there is a flag in sort which is interesting. So if I go ahead and use the R flag here, it is going to return the same but in reverse order. Sudo comes in the beginning and cat comes in the end. Then you have a flag also in sort that I just remembered called n. And it puts it back in numerical order that we had put it in before. With that, we come to the end of your sort command. All right, clearing this out. Next, we have that set of copy, move, and remove. So copy, pretty simple. You're basically going to try to make a copy of your file in any given directory. So as you can see, first I'm going to list out what's there in this directory. Let's put in a path. Let's see what's there in public. There's just this one file there in public called text.txt. So what I'm going to do is I'm going to copy this Linux file into this path. At this point, this might look very redundant because we all know what the copy command does. But since it's there, let's do it anyway. And now, as you can see, your Linux command is there, and so is text. And that's about all that copy does. Now, there's also a flag which I wanted to discuss with copy. Now, I'm going to show various versions, some different flags with every command that I'm doing. I'm making it extensive. I'm sorry, I'm not trying to be boring, but I'm doing this extensively because I'm going to try to make it like a complete manual towards all the basic commands that you can use in Linux. So this particular flag is called verbose, which basically prints out the complete information of the process that is happening. So if I'm going to type the same thing again, it is going to show me what I am doing. So basically what did I do was I overwrote my Linux commands text file that was there. in public. Let me give you a better example of this. What I'm going to do is I'm going to create a text file called ABC. Let's just type anything. Okay. Now this is where I want you to see the difference between copy and copy with a verbose flag. So I'm going to clear this out. I'm going to copy ABC into the same file where we had copied our previous text file. Home, Edureka, public. And basically, it gives you this information that you're copying this particular file to this particular destination, if you may. Because this is a small file, it does not really matter. But imagine if you're trying to move a file which is like 10 GB, then it is going to take you time, and using the verbose command is going to give you continuous information and inform you when a background process that you're running is done. Now you have the same flag option in move as well. So we're going to try and move a certain file. Let's create a file for that. Let's just create a bunch of random files so I can show you how these things work. So again, we did ABC. Now let's do DEF. Okay. All right. Now we have a file called def.txt. Now what I did before was I created a copy, so there remains a copy of ABC here. But since now I'm trying to move this, simple type mv def. You can press tab every time that is going to complete your particular command that you're typing, or elements of the command if you may. I'm going to put it again, public. Seems like this is my favorite directory because it's empty like most of the time. So I move this. Now I am going to check if it's been moved. So as you can see, the def.txt file is there in public. Now let's check if it's there at home. As you can see, my mouse decides to ditch me right now. The def was here before I used this command, and now it isn't there. So basically that's what it did. It moved the def file from your Edureka directory to your public. Now I'm going to remove it using remove. So let's just remove this ABC thing. ABC. Alright, what it did, it removed ABC. Now, as I had mentioned before, there is nothing known as the recycle bin in Linux, which is one of its advantages if you look at it, because it keeps the whole system decluttered, but also you do not have the safety net of a recycle bin when you remove a certain file. So be very careful while using the rm command, alright? With that, let's go ahead and see how you can make a directory using mkdir, which basically means make directory. So you can make directory using this command. So mkdir, I'm going to make a directory called demo. So as you can see, it's in blue. That means it's a directory. Now there's something else also known as touch, which I forgot to list earlier. This you can use to create many files at the same time. File1.txt, then I'm going to do file2.txt. As long as you keep separating them using a space, they're going to be created as separate files. As you can see, you have your file1, file2, and file3. Remember the touch command to immediately create files. Then you can go ahead and use the file however you want. Then you have the option of removing the directory that you created, which is rmdir, which stands for remove directory. Pretty self-explanatory. So I'm going to remove that very file that I created moments ago. and as you can see, does not exist anymore. Now we're done with this section of Linux commands as well. Now I have this final bit of commands that I wanted to show you guys. Now there is something known as chmod, which also means change of mode. It basically is used to change the access permissions of files and directories. For that, let me recapitulate a little bit. Remember, I had used something known as long list, right? On the leftmost column, you can see the permissions that are associated with a certain file. All right? So these are the permissions. Now remember, any file that you have just created is not always executable. So for that, I'm going to create a new file. I'm going to create a little script, if you may. So let's call it name. All right. And this is going to be pretty simple. It's going to start with the shebang line. And then it's just going to have like one echo line, which says, hello world, because we haven't used this a bajillion times already. So there you are. Now what if I try to execute that script? Let me try to execute that script. Do you see something here? It says permission denied. Now if I viewed this in long list, let's see, n. This is my line. As you can see, you cannot see X anywhere. X stands for execute. So it is readable and writable by the user, and it is only readable by the user group and readable by everybody else. Now by default, these are the permissions that are associated with the file. For that, I can do something called chmod, and then go ahead and do +x, which is make it executable, or you can do a +r for make it readable or writable, +x, and then go ahead and then you can run it. Hello world. Okay, now this is when you want to separately just do a +x or make it executable, or +r make it readable, or +w make it writable. But what if you wanted to change all the permissions which are associated with that particular file? Let me create another new file which will have the same contents to give you a better view of this. Let's call it name new. All right, because I'm not original at all. So same thing again. What I'm going to do is I'm going to try to print hello world, because cliches are romantic. So again, another thing that I could do to change the permission is chmod 777, and then the same thing, which I'm going to type name new, and then try running it. As you see, it printed it out. Now, what does this 777 mean? For that, I'm going to open the nano editor again, and I'm going to call this change permissions.txt. So basically, your chmod will always be in this particular syntax. You'll have your chmod, that is the command. Then you'll have 3 digits, which previously I typed 777. So your first one is going to be your user, your second one is going to be the group, and the third one is going to be others. And then you're going to type the file name and the file extension. All right. So remember, user, group, and then others. Now, depending on what numbers that you put in place of user, group, and others, there are going to be permissions of access which are going to be allotted to that particular file. So now these numbers will go from 0 to 7, and I'm going to tell you what each of these numbers mean. So first of all, you have 0, 0 amounts to 0. There's a reason why I am typing it this way. Have some faith in me. You'll understand a little later. And 0 basically means no permission for nobody at all. So nothing. Then we have 1. It's equal to 1, which means make it executable. Also represented by X. Then you have 2, which is equal to 2. And this means it is writable. So also I'm going to use W later for this. Then you have 3, which is 2 plus 1. So if you apply a little logic, it means you can write and execute this. You're getting a feel of what I'm saying here? Then you have 4, which is equal to 4, and it means you can read. Similarly, 5 is equal to 4 plus 1, which means you can read and execute. Then you have 6, which is 4 plus 2, which means read and write. And then you have 7, which is 4 plus 2 plus 1, which also means you can read, write, and execute a certain file. Now, when I typed chmod 777 and said file name, what first 7 meant was the user could read, write, and execute the file. The second meant the groups could read, write, and execute the file. And the third meant everybody else could also read, write, and execute a certain file. So this you have to do before you try to execute any new file, or you can just go ahead and do a plus X if that is easier for you. I personally like just giving out all the permissions straight out, but when you handle a little sensitive information, doing this might not be the wisest. All right, I'm not going to save this. I'm straight up going to get out of there. Let me clean this out, make this a little cleaner. Now, apart from that, there are certain things I would like to discuss, which I am not going to be executing them, but it's a good thing to discuss them. This is where you shall understand. I'm naming this sudo. Remember, I had mentioned this earlier. I'm going to discuss this later. So basically, stable versions of most softwares will already be available in the Linux repositories. What you need to do is you just have to command to install them. So for that, you need to go to your super user to be able to install certain packages. So everything that I'm going to install, all the commands are going to start from sudo. Now, if it is an RHEL or Red Hat Enterprises Limited based system, then you're going to go yum, install, and then go ahead with the name of your package. So you use yum when it's RHEL, like CentOS. Anything that I have to install here, I am going to have to do same thing sudo, but you use apt-get for Debian based systems. So you go ahead and install. It's pretty much the same syntax. And then same thing you do for Fedora based systems. So DNF. And then you go ahead and do your install packages. Now let me see. Should I try to run something and show you guys? It might just take some time, but I think I want to do this, so I'm not going to save this either. Let me just run something and show you guys so you know how these things are installed. So what I'm going to try to do is I'm going to install this BC Math extension. So again, go ahead and do this sudo yum install and php bc math. So this might take some time, be a little patient. And with that, you can see your math package is completely installed.
These are the frequently used commands like while you're working in DevOps. Okay, I'm just showing you the list. Then we will practically see how to use these commands on the command prompt. So these are the few commands. I've tried to cover maximum number of commands so that you're comfortable working with DevOps. So now let us try to execute these commands in a Linux based system. So in my system, I've installed Ubuntu operating system. So let us start with the basic commands in Linux. So the first command that you must know is the man command. Man stands for manual. Like if you want to know about any command in Linux, you can just type man space the name of the command. Say for example, you have to know about ls, say for example, just type man space ls. So ls is a command. We'll talk about it later. So just press enter. Okay. So here it shows the name of the command, its syntax, and the description. Like if you want to know what it is and what it does, so you can use man command for it. So the next command that you should know is the clear command. If you want to clear your terminal, just type clear and press enter. So this clears your terminal. So the next command that you must know is, say for example, if you want to know where is your current working directory. For that, there is a command called pwd, that is present working directory. Simply type pwd and press enter. Okay, so here it says home Edureka. So this is my current working directory. And if you want to change your directory, for that there's a command called cd, that is change directory. Suppose from home Edureka, you have to switch your working directory to home. So simply type home. Okay, so if I now type pwd, it says home. So this was another basic command. So the next command is echo command. Say if you want to type anything, like if you want to print anything on the terminal, so you can use echo command for that. Say for example, echo hello world. So I have to print these two words on the terminal. For that, I'll use the echo command. Okay, so it says hello world. Pretty simple. So the next command is su command. Let's see first who is the current user. For that, there's one more command called who am I. Okay, so here it says Edureka. So Edureka is the current user of this system, the Linux system. So if you want to switch to the root user who has all the permissions, as of now, the Edureka is not a super user. He doesn't have any permissions related to file operations or any other operations. So root is a user, the basic user. He has all the permissions on this Linux OS. So if you want to switch to the root user, so simply type su, press enter. It'll ask for a password, type the password. So here it says authentication failure. So there's one more command, bash sudo bash. Okay, so before it was Edureka here and now it is root here. So if I type who am I, so here it says root. Okay, so in case if this doesn't work, su doesn't work for any reason, so you can use this command called sudo bash. So it switches to the root user. And if you want to switch back to Edureka, simply type su and the username. Okay, so you're back to the Edureka user. Okay, these are very basic commands, guys, but you must be knowing this. So the next command is the sudo command. So sudo command is for user who doesn't have a proper permissions or privileges for executing some commands or operations. So in that case, you have to use a sudo command. So say for example, adding a user, deleting a user, adding a group, and many other commands that we will see in the upcoming commands. So I'll just give you a few examples here of sudo. For example, you have to add a user. So adding a user, deleting a user, that is mostly done by the root user. So he has all the permissions to add a user and all. So say for example, if you have to add a user, So the command for that is sudo user add and the name of the user. Say for example, Arvind. Oh, it says Arvind already exists. So type Arvind11. So it has created a user. And say for example, if you have to add a password to this user, so the command for that is sudo passwd and the username. So it will ask for a password that you need to set. You can type whatever you want, retype it. So it has created a user and it has also added a password for that user. So say for example, you have to delete this user. So the command for that is sudo user delete user del and the username Arvind11. Okay, so the user has been deleted. Say for example, you have to add a group. A group can have multiple users. Okay, so you have to add a group to the system. So the command for that is sudo group add and the group name. So you can say the group name as techies. Okay, so the group has been added. Similarly, if you want to remove this group, sudo group del and the group name. Okay, pretty simple. So let me just clear my terminal. So the next command that we are going to talk about is the touch command. So the touch command is used to create any file on your system. Say for example, I have to create a file, a text file. You can give whatever name, abccba.txt. Oh, it says permission denied. Okay, so here we are going to use the command sudo. So it has created a file called cba.txt. And how can we see that? Simply type ls. Can you see here the file that we have just created, the cba.txt. So this is the use of the touch command to create a file. So the next command that we are going to talk about is the text editor command. Say for example, vi, nano, vim, gedit and so on. So the vi editor is the most popular and a classic text editor in the Linux family. So to use it, say for example, you have to write something into that file. So for that purpose, you will use sudo vi and the name of the file cba.txt. Okay, so press enter. The file has been opened now and press I to insert anything into this. Say for example, hi, this is Edureka. So to save this file, simply press escape, W for write and Q to quit. So our file has been saved. So there's one more command called cat command. So this command can read, modify or concatenate text files. So this command is also used to display the contents of the file. So say for example, I've written something into this file called cba.txt. Now I have to display the contents of this file. So what I'll do is cat and file name cba.txt. So here, this was the line that I had written in this file cba.txt. So the cat command can be used for that. So there are also other flags that can be used with this command. Say for example, -b. So the command would be cat -b and the file name. So this is used to add line numbers to the non-blank lines. So the next flag is -n, that is cat -n. So this command is used to add line numbers to all the lines that are present in the file. Cat -s is used to squeeze blank lines into one lines. And cat -E, it shows the $sign at the end of the line. So these were a few flags that you can use with cat command. So let me just clear the terminal. So the next command that we are going to talk about is the copy command. This command is used to copy files and directories. A copy of the file directory still remains in the working directory. So let me just show you how do you use this command. So it is very simple. Copy, so say for example, cba.txt, I have to copy this file to the location. Say for example, home Edureka. Right now we are at the home location. I have to copy this file to this location, home Edureka. Okay. So the command is very simple, cp, file name and the destination name. So press enter. So let us now see whether the file has been copied there. So for that, we'll have to switch to that location. cd Edureka. So let us use the ls command. Okay, so here you can see the cba.txt file has been copied. So this was a very simple command. And there are a few flags that you can use along with this command. So there's a flag called -n, that is cp-n and the file name. So this does not overwrite the file. The next flag is the -u, that is cp-u. So this command updates the destination file only when the source file is different from the destination file. There's one more flag called -R, that is cp-R. So this command is a recursive copy for copying directories, and this command even copies the hidden files. So these were a few flags that you can use with the copy command. So the next command is the move command or the mv command. So this command moves the files and the directories from one directory to the another. The file or the directory once moved is deleted from the working directory. So this was not the case with the copy command. So I hope you get the difference between copy and move. So let us see what is the syntax for this. So the syntax is mv, the flag name, like if there are any flags here, the file name, and the destination name. Okay, the path to the destination. So let us just say first we'll have a look at the files that are present here. Okay, so demo.txt. Can you see this file here? So we'll try to move this file to the home folder. So the command is very simple, mv, the file name, demo.txt. It says permission denied, so just simply use sudo. Okay, the file has been moved. Let us now verify this. cd. Okay, so we are here at the home folder. Simply use ls command. So as you can see here, demo.txt has been moved. So this was a very simple command and easy to use command. There are three flags that are associated with this command. mv-i. So this command enters into an interactive mode and the command line asks before overwriting the files. So the command mv-u updates the destination file only when the source file is different from the destination file. And the third flag is the mv-v. So this command enters the verbose mode, and this command prints the source and the destination file. So for those who are not aware of what verbose mode is, so verbose mode provides additional details as to what drivers and softwares it is loading during the startup. So this was all about the move command. So the next command that we are going to talk about is the rm command. So this command removes files from a directory. By default, the rm command does not remove directories. Once removed, the contents of the file cannot be recovered. So the syntax for this is very simple, rm, the flag name, and the file name. That's a very simple command and easy to use command. So I'll just show you how to use this. Say for example, I have to remove this file demo.txt. So simply I'll type rm in the file name demo.txt. Oh, it says permission denied. So the file has been removed, and let us just verify this. Okay, so we cannot see anywhere the demo.txt file, so it has been removed. So this was a very simple command, rm. So there are two flags that can be used along with this command. The first flag is the rm-r. So this command removes even the non-empty directories, and the other flag is rm-rp. So this command removes the non-empty directories, including the parents and the subdirectories. So this was the rm command. So the next command that we're going to talk about is the mkdir command. So if you want to create a new directory, then this command can be used. It's a very simple command, and the syntax is even more simple. So if you have to create a directory, simply type mkdir and the directory name. So say for example, in home, I have to create a directory called techies. It says permission denied, no issues. So the directory has been created. Let us just verify this. So as you can see here, this directory has been created here at this location, the home folder. So the flag that can be used with this command is -p, that is mkdir-p. So this command creates both a parent directory and a subdirectory. And if you want to create multiple files into a directory, you can use the command mkdir-p and the file names. So this command will create multiple subdirectories inside the new parent directory. So let me just clear the terminal. The next command is the rmdir command or the remove directory command. So this command is used to remove a specified directory. Although by default it can remove only an empty directory, there are flags which can be deployed to delete the non-empty directories as well. And the syntax for this command is very simple. Simply type rmdir, the flag name, and the directory name. Okay, so very simple. Let us just see how do you remove a directory rmdir. So let us just remove the directory that we created in the previous command rmdir, and the name was techies. Sudo rmdir techies. Okay, so the directory has been removed. Let's just verify this. So there's no directory called techies here as it has been removed by the rmdir command. So there are a couple of flags that you can use with this command. The first flag is -p, that is rmdir -p. So this command removes both the parent and the child directory. There's one more flag called -pv. So the command is rmdir -pv. So this command removes all the parent and the subdirectories along with the verbose. So I hope you're clear with this command rmdir. So the next command that we are going to discuss is the grep command. So this command is used to search for a particular string or a word in a text file. So this command is similar to Control F, but this is executed via a command line. So let me just show you how do you use this command. So let us say, for example, let me have a text file here. So the syntax for using this command is very simple. So say, for example, we have a file here called grep test, as you can see here, this one. So let me just see the contents of this file using cat command, grep test.txt. So this file has these words: dog, apple, ball, cat, cat, mouse. So say, for example, I have to search the word cat in this file. So for that, I'll use the command grep, the word cat, and the file name grep test.txt. Okay, so as you can see here, the word cat has been highlighted just because it is present in this file. So say, for example, we want to search for a word that is not present here. So say, for example, cat1 or any other word. So say, for example, mad. Okay, so it is not showing anything. That means that this word is not present in this file. So this was a very simple command, grep. And there are a few flags that you can use with this command. So say, for example, grep -i, and obviously the file name. So this command will return the results for case insensitive strings. So there's one more flag called -n, that is grep -n. So this command returns the matching strings along with their line numbers. The next flag is the grep -v. So this command returns the results of lines not matching the search string. Next flag is grep -c. So this command returns the number of lines in which the results match the search string. So the next command that we are going to talk about is the sort command. So this command sorts the results of a search either alphabetically or numerically. Files, file contents, and directories can be sorted using this command. The syntax for this command is very simple. Let me just see the files that are present here. So there's a file called sort test. So let me just see the contents of this file, sort test.txt. Okay, these are the words that are present in this file. So I have to just sort these words. Okay, so the command for that is sort the file name, sort test.txt. So as you can see here, these words have been sorted alphabetically: B, D, F, M, S, and T. So this is the use of sort command. And there are a few flags that you can use with this command. Like the first flag is sort -r and the file name, obviously. So this command returns the results in reverse order. So there's one more flag called -f. So this command does the case insensitive sorting. So whether you have uppercase words or alphabets or whatever in your file, so irrespective of the case, this command will sort the file. And there's one more flag called sort-n. So this command returns the results as per the numerical order. So say for example, you have numbers in this file, and if you want to sort them numerically, like ascending order, that can be done using the command -n. So this was pretty much about the sort command. So let me just clear the terminal. So the next command that we are going to talk about is the chown command. So different users in the OS have ownerships and the permissions to ensure that the files are secure and put restrictions on who can modify the contents of the file. In Linux, there are different users who can use the system. So each user has some properties associated with them, such as the user ID and a home directory. We can add users into a group to make the process of managing the users easier. A group can have 0 or more users. A specified user can be associated with a default group. It can also be a member of other groups on the systems as well. So if you talk about the ownerships and the permissions, so to protect and secure the files and directories in Linux, we use permissions to control what a user can do with a file or a directory. So in Linux, there are three types of permission: the read permission, the write permission, and the execute permission. So the read permission allows the user to read files and directories. It lets the user read directories and subdirectories stored in it. The write permission allows the user to modify and delete a file. Also, it allows a user to modify its contents for the directories. So unless the execute permission is not given to directories, changes do not affect them. The third permission is the execute permission. So the write permission on a file allows it to get executed. For example, if we have a file named php.sh, so unless we don't give it an execute permission, it won't be run. So these were the permissions. Types of file permissions in Linux, there are three types. The first one is the user. So these type of file permission affect the owner of the file. The second one is the group. This type of file permission affects the group which owns the file. So instead of the group permissions, the user permissions will apply if the owner user is in this group. The third permission is the other permission. So these type of file permission affect all the users on the systems. So to view these permissions, so let us just say we use a command ls-l. So this command will list down all the files and the directories that are present here along with their permissions. So as you can see here, these are the permissions, these are the users, the groups, and the timestamp. And these are the names of the file. To use this command, so say for example, there's this file called abc.txt whose user is Edureka. Okay, so you have to use this command chown. So the syntax for that is pretty simple. Chown, the owner name, the owner that you want to change. So say for example, root, and the file name. So file name is abc.txt. Operation not permitted. Sudo. Let me just try sudo. Okay, so this works when you use sudo. So let us now just run the command ls-l to see the permissions of this file. So as you can see here, it was first Edureka. Now let us see the changed owner. Okay, so previously it was Edureka and now it is root. Okay, so this is how you use the chown command. So just to summarize, the chown command is used to change the owner and the group of the file. So the next command that we are going to talk about is the chmod command. So this command is used to change the access permissions of files and directories. So the syntax for this command is pretty much simple. So say for example, if you want to change the permissions and the privileges of a file. So for that, let us just see the list of files that is present here and the permissions. So say for example, this file bac.txt, it has these permissions. So we want to give all the permissions to all the users and the groups that want to use this file. So for that, let me type the command chmod 777. Okay, and the file name bac.txt. Okay, so let us again have a look at the permissions of this file. Okay, so as you can see here, previously these were the permissions: read, write, read, and read. And now it has changed to read, write, execute for the user, the group, and the others. Okay, so there are a few numbers that are associated with the permissions, like 0 means no permission at all. 1 means the execute permission, 2 means the write permission, and 4 means the read permission. So here we have used the command chmod 777. So 7 here means read, write, execute, all the three, 4, 2 and 1. So read, write, execute for the user, the second 7 is for the group, and the third 7 is for any other users or the groups. So this was the chmod command, and I hope you have understood this command. So let me just clear the terminal. So the next command that we are going to talk about is the lsof command. So while working in Linux or Unix based system, there might be several files and folders which are being used. Some of them are visible and some of them are not visible. So lsof stands for list of open files. So this command provides a list of files that are open. Basically, it gives the information to find out the files which are opened by which process. So with one go, this command lists out all the open files in the output console. So the syntax for this command is pretty much simple. Let us just type lsof. So as you can see here, this is the list of open files. These many files. Okay, if you scroll. So here you observe there are details of which files are open, the process ID, the user associated with the process. FD stands for file descriptor. Size of the file altogether gives detailed information about the file opened by the command, the process ID, its user, and so on. So CWD here stands for current working directory. Okay. TXT stands for the text file, obviously. So say for example, if you want to know the list of all files opened by a particular user. So there are several users of a system and each user can have different requirements, and accordingly they use files and devices. So to find a list of files that are opened by a specific user, you can use the command, say for example, lsof -u and the username, say for example, Edureka. So these are the lists of files that are opened by the user Edureka. Let me just clear the terminal. So then next command that we are going to talk about is the id command. So the id command in Linux is used to find out user and the group names and numeric IDs of the current user or any other user in the server. So this command is used to find out a few important things such as the username and the real user ID, find out the specific user's UID, show the UID and the groups associated with a user, list out all the groups a user belongs to, and display the security context of the current user. The syntax for this command is pretty much simple. ID, the flag, and the username. Okay. So there are a few flags that you can use with this command. The first flag is the -g. So the command would be ID -g and the username. So this command prints only the effective group IDs, whereas ID -G prints all the group IDs. ID-N prints the names instead of numbers, and ID-R prints real IDs instead of numbers. ID-U prints only the effective user ID. ID-help displays the help messages. ID-version displays the version information. So without any option, it prints every set of identified information, that is the numeric IDs. So what you need to do here is simply type ID and press enter. So as you can see here, it displays the UID for this user Edureka, the group ID, and the group that he belongs to, and the respective group IDs as well. So say for example, if you want to know the user ID for this user called Edureka, ID-U, Edureka. So 1000, as you can see here, user ID is 1000 and group ID is also 1000. Let me just verify this. The command for that is ID-G. Okay. 1000, as you can see here. So to find out all the UIDs and the groups associated with the user, so say for example, there's another user called Arvind. So ID Arvind. So as you can see here, the outputs, user ID, group ID, and the groups that he belongs to. So this was about the ID command. So the next command that we're going to talk about is the tar command. So the tar command is used to zip and unzip files of the .tar format. So let me just show you the syntax for this file. So say for example, if you want to zip a folder, so for that the command is tar hyphen cvf space file name and the folder name, source folder name. So this was a very easy syntax for the tar command. And say for example, if you want to unzip a file, so in DevOps, while installing something, you might be getting a file in the .tar format. While unzipping that file, you can use this command tar hyphen xvf and the tar file name. So you can use this command to unzip a file. So this was about the tar command. The next command that we are going to talk about is the cut command. So cut command is used for extracting a portion of a file using columns and delimiters. So say for example, if you want to list everything in a selected column, then in this case, you need to use the -c flag with the cut command. So say for example, let me just see here. So there's this file called So let me just show you how do you use this command. So let us first see what are the files present here. So say for example, this file demo1.txt. Okay, so this file has these lines A11, B22 and C33. So say for example, if you want to display only two columns like A1, B2 and C3 from this file, so using cut command we can do it. So the syntax for doing that is very simple: cut hyphen C1 hyphen 2 space the file name. So the file name is demo1.txt. So hyphen C here stands for the column, and which columns? 1 and 2 column. Okay, so just press enter. Okay, as you can see here, it will display these two columns. So say for example, you want only one column and not the two columns. So just remove this 2 hyphen C1, press enter. So you can see here A, B, C, only the first column is displayed. Okay, so this was about the cut command. So the next command that we are going to talk about is the SED, that is sed command. So sed is a text editor which can perform editing operations in a non-interactive way. So sed command gets its input from a standard input or a file to perform the editing operations on a file. So sed is a very powerful utility and you can do a lot of file manipulations using sed. So say for example, if you want to replace a text in a file by searching it in a file, you can use the sed command with the substitute s flag, small s, to search for the specific pattern and change it. So say for example, let me just show you an example here. There's this file called demo. So sed test. Okay, so cat, let me just see the content, this file, sed test dot txt. Okay, so here it says, how are you, Baban? So say for example, I have to replace this Baban by any other name. So I can use the sed command here, sed space single quote s, that is the flag that you can use with this command. So the word that you want to replace and the new word, Chagan. Okay, and the name of the file, obviously sedtest.txt. So as you can see here, first it was how are you, Baban, and now it is how are you, Chagan. So this was the command sed. I hope you have understood this command. We just clear the terminal. Okay, so the next command that we are going to talk about is the unique command. So unique command is used for filtering out the duplicate lines in a files. So the syntax for this command is pretty much simple. So say for example, you have to remove all the duplicate lines from a file. So you can use this command unique and the file name. So this was a very easy command. The next command that we are going to talk about is the watch command. So watch command in Linux is used to execute a program periodically showing output in full screen. This command will run a specified command in the argument repeatedly by showing its outputs and errors. By default, the specified command will run every 2 seconds and watch will run until interrupted. So the syntax for this command is very simple. You just have to type watch, the flag, and the command. Let me just show you an example using this. So there's this flag called -d that you can use with watch. So this parameter -d highlights the differences between the successive updates. The options will read the optional arguments, which changes the highlight to be permanent, and this allows the user to see what has changed at least once since the first iteration. So let me just type -d, watch -d free -m. Free command we have used. We'll see what free command is in the later part of this session. So the next command that we are going to talk about is the eval command. So eval is a built-in Linux command which is used to execute arguments as a shell command. So it combines arguments into a single string and uses it as an input to the shell and execute commands. So the syntax for this command is very simple, eval and the arguments. So let me just show you an example of eval command here. So say for example, you have to type eval help. Eval help. This command shows the description of the eval command itself. So as you can see here. So let me just clear the terminal. So the next command that we are going to talk about is the history command. History command is used to view the previously executed commands. This feature was not available in the Bourne shell. Bash and conch shell support this feature in which every command is executed and is treated as the event and is associated with an event number using which they can be recalled and changed if there's a requirement to do so. So these commands are saved in a history file. So in Bash, shell history command shows the whole list of commands. So say for example, just type history here, press enter. So this is the list of commands I've used till now. 400, 500 plus commands, I guess. Yeah, 584 commands I've used. So say for example, if you want to see only last 5 commands that I've used, history space 5, press enter. So these are the last 5 commands that you have used. You can see here. Let me just clear the terminal. Okay. So the next command that we are going to talk about is the dd command. So dd is a command line utility for Unix and Unix-like OS whose primary purpose is to convert and copy files. The command line syntax of dd differs from many other Unix programs in that it uses the syntax option equal to value. So this syntax option equal to value is used for its command line operations. So I'll show you just a practical example of this command. So say for example, you have to back up the entire hard disk. So to back up an entire copy of a hard disk to another hard disk connected to the same system, so this command dd can be used. In this command, the Unix device name of the source hard disk is, say for example, the source hard disk name is dev hda and the target hard disk name is dev hdb. So how do you use this command dd space if stands for input file space the name of the source hard disk. So it is dev space hda, and I just forgot to place equal to sign here. As discussed earlier, it has a syntax of option equal to value. So input file is this, the source file, and the output file of is dev slash hdb. So as of now, we are not copying anything. So, but I'm just showing you how to use this command. So input file and output file should be mentioned very carefully. Just in case you mention source device in the target and the vice versa, you might lose all the data. I hope you have understood this command. Okay, so there's one more command that we talked about, like the free command. Okay, so the free command displays the total amount of free space available along with the amount of memory used and swap memory in the system, and also the buffers used by the kernel. The syntax for this command is very simple, free space or options, you can say. So let me just type free command here and press enter. So as you can see here, total installed memory that is present on the system. So used means the used memory and free means the unused memory. Shared displays the memory used by the temp folders. Buffer displays the memory used by the kernel buffers. And cached displays the memory used by the page cache and the slabs, and buffers slash cache displays the sum of the buffers and the cache. And there are a few flags or options that you can use with this command, that is -b. The command is free -b, so it displays the memory in bytes. If you use -k, this displays the amount of memory in kilobytes, which is by default. -m displays the amount of memory in megabytes, and -g, small g, displays the amount of memory in gigabytes. I hope you have understood this command, free. So let me just clear the terminal. Okay. So the next command that we are going to talk about is the SSH command. So while working in DevOps, you might frequently use this command, the SSH command. So SSH means that secure shell. Okay. So this command refers to a cryptographic network protocol for operating network services securely over an unsecured network. Typical use cases include remote command line execution, but any network service can be secured with the command SSH. So say, for example, if you have a master node and the slave node. So if you are running this command, the command that I'm going to type now on the slave node, this will give you access to the master node. So the command for that is very simple, SSH and the master's IP address. So if you run this command on the slave machine, you can get access to the master machine. And vice versa, if you execute this command on the master machine along with the slave IP, you can get access to the slave machine. So there's one more command called SSH keygen. So this command is used to generate a public-private authentication key pair. So authentication keys allows a user to connect to a remote system without supplying the password. So keys must be generated for each user separately. So if you generate key pairs as the root user, only the root user can use those keys. So the syntax for creating pair of keys is very simple. So you need to type SSH-keygen space -t and RSA. Press enter. Here you can press enter. It says it already exists. So I want it to overwrite. Press enter. Enter passphrase, empty for no passphrase. Enter passphrase, press enter. Press enter. Okay. So the key has been generated, as you can see here. -t option here is used to specify the type of key that you have to create. So you have the option of specifying the passphrase to encrypt the private part of the key. So if you encrypt your personal key, you must supply the passphrase each time you use this key. So in this case, we have just pressed enter. We haven't pressed anything in the passphrase. So this prevents an attacker who has access to your private key and can impersonate you and access all the computers you have access to from being able to do so. So this was about the command SSH keygen. Let me just clear the terminal. So the next command that we are going to talk about is the IP command. So the IP command in Linux is present in the net tools, which is used for performing several network administration tasks. IP simply stands for Internet Protocol. So this command is used to show manipulative routing, devices, and tunnels. It is similar to the ifconfig command. Okay, the next command that we are going to discuss is the ifconfig command. So ifconfig, that is interface configuration command, is used to configure the kernel resident network interfaces. It is used at the boot time to set up interfaces as necessary. After that, it is usually used when needed during debugging or when you need a system tuning. Also, this command is used to assign IP addresses and net mask to an interface or to enable or disable a given interface. So the syntax for this command is very simple, ifconfig space options and space the interface. So there are two options that you can use with this command, that is ifconfig -a. So this option is used to display all the interfaces available even if they are down. So if you use this command ifconfig -a, okay, so you can see all the interfaces that are available. Okay, yeah. And there's one more command called -s. So if you type ifconfig -s, so this displays a short list instead of all the details. So this was about the ifconfig command. So let me just clear the terminal. Also, if you want to know the IP address of your machine, you simply need to type ifconfig, press enter. Okay. As you can see here, this is the IP address of your machine. So to know the IP address of your machine, you just need to use this command ifconfig. So let me just clear the terminal. The next command that we are going to talk about is the IP command. So IP command in Linux is present in the net tools, which is used for performing several network administration tasks. So IP stands for Internet Protocol. This command is used to show or manipulate routing, devices, and tunnels. It is similar to the ifconfig command, but it is much more powerful and more functions and facilities attached to it. ifconfig is one of the deprecated commands in the net tools of Linux that has not been maintained for many years. IP command is used to perform several tasks like assigning an address to a network interface or configuring network interface parameters and so on. So it can perform several other tasks like configuring and modifying the default and static routing, setting up a tunnel over an IP, listing IP addresses and property information, modifying the status of the interface, assigning, deleting, and setting up IP addresses and routes. So let me just show you a practical example of IP space address. Okay. So this command is used to show all the IP addresses associated on all network devices. So as you can see here, these are the various network devices and their IP addresses. Yeah, so there's one more command called IP space link. So this command is used to display link layer information. It will fetch characteristics of the link layer devices currently available. Any networking device which has a driver loaded can be classified as an available device. So IP-link, press enter. Okay. So this is the output. These are the available devices and the link layer information, as you can see here. So let me just clear the terminal. So the next command that we're going to talk about is the netstat command. So netstat command displays various network related information such as network connections, routing tables, interface statistics, multicast memberships, and so on. So the syntax for this is very simple. For example, netstat and -a. So as you can see here, if we use this command netstat-a, so it is used to show both the listening and the non-listening ports that are available. So this command is used to show both the listening as well as the non-listening sockets. And there's one more command called netstat-at. So this command will list all the TCP ports that are available. So as you can see here, these are the TCP ports. So this was about the netstat commands. So the next command is the nslookup command. So nslookup stands for name server lookup. This is a useful command for getting information from the DNS server. It is a network administration tool for querying the domain name system to obtain domain name or IP addresses, mapping, or any other specific DNS record. It is also used to troubleshoot DNS related problems. So the syntax for this is very simple. Simply type nslookup and the option. Let me just type nslookup, say for example, google.com. So it is giving you the details of this domain, google.com, the server, the address. So if we type this command like ns and the domain name, so this will display a record that is IP address of the domain, as you can see here. So this command queries the domain name servers to get all these details. So this was about the nslookup command. Let me just clear the terminal. So the next command that we are going to talk about is the curl or curl command, as you can see. So curl is a command line tool to transfer data to or from a server using any of the supported protocols such as HTTP, FTP, SCP, SMTP, and so on. So curl is powered by a libcurl. So this tool is preferred for automation since it is designed to work without any user interaction. So curl can be used to transfer multiple files at once. So the syntax for this command is very simple. Curl hyphen space, I repeat, curl space options and the URL. So there's one parameter or the option that you can use with this is -o. So this parameter saves the downloaded file on the local machine with the name provided in the parameters. So this was about the curl or the curl command. So the next command that we are going to talk about is the awk command. So awk is a scripting language used for manipulating data and generating reports. The awk command programming language requires no compiling and allows the user to use variables, numeric functions, string functions, and logical operators. So AWK is abbreviated from the names of the developers, that is Aho, Weinberger, and the Kernighan. So the syntax is pretty much simple. I'll show you how do you use it. So say for example, let me see the list of files that we have. Okay, so cat abc.txt. So let us just see the contents of this file abc.txt. Let's just see another file demo1.txt. Okay. demo1.txt. Okay, so I'll just show you how do you use this command. So say for example, you want to print every line from a specified file. So we can use this command awk single quote curly braces. Okay, and the name of the file. So say for example, awk test.txt. Okay, so this was the file. This has only 2 lines. Okay, so if you want to print every line from a file, so you can use this command awk. So say for example, I'm looking for a specific pattern in a file. So say for example, awk, I'm looking for the word. Okay, so let's consider this file itself in single quotes. I'm looking for RAM and I want to print it. And the file name awk test.txt. So it will print any of the lines that has this word RAM. Press enter. Okay, so these 2 lines have this word RAM, so it has printed both these lines. So this was another use of awk. So the next command that we are going to talk about is the tr command. So tr stands for translate. So this command in Unix is a command line utility for translating and deleting characters. It supports a range of transformations, including uppercase to lowercase, squeezing repeating characters, deleting specific characters, and basic find and replace. It can be used with Unix pipes to support more complex translations. Okay, so I'll just show you an example of the tr command. So say for example, this file called awk test. Okay, so let us just see the contents of this file. Now we'll try some other file, cba.txt. Okay, so let us just say we want to convert this into uppercase, everything into uppercase. Here we want to display this, hi, this is Edureka in uppercase. So for that we will use the command cat, the file name cba.txt, and the pipe symbol tr space double quotes a to z space and the capital A to Z. Okay, so this is the syntax for doing this. press enter. As you can see here, everything has been converted to uppercase. So this is one of the usage of the tr command. So let me just clear the terminal. The next command that we are going to talk about is the env command. Env command is used to print environment variables. It is also used to run a utility or a command in a custom environment. In practice, env command has another common use. It is often used by shell scripts to launch a correct interpreter. In this usage, the environment is typically not changed. So say for example, I have to see a list of all the environment variables that are present on my system. So I'll simply type env and press enter. Okay. So these are the list of environment variables that are present. Say for example, if you want to run a command with an empty environment. So for that, the syntax is env hyphen I and the command. Okay. And say for example, if you want to remove a variable from the environment. So for that, the syntax is env hyphen u and the variable name. Okay. So I hope you have understood this command env. Let me just clear the terminal. So the next command that we are going to talk about is the iptables command. Iptables is a command line interface used to set up and maintain tables for the NetFilter firewall for the IPv4, including the Linux kernel. The firewall matches packets with rules defined in these tables and then takes the specified action on a possible match. So I'm going to tell you the usage of the iptables commands. So say for example, while working in DevOps, for some reason you need to disable the firewalls. So for that, this command iptables can be used. Say for example, service iptables stop. So this command can be used to disable the firewalls. Okay, so this was one use of the command called iptables. Okay, so as of now we are not running this command on our system. So the next command that we are going to talk about is the apt-get command. So apt-get is a command line tool which helps in handling packages in Linux. Its main task is to retrieve the information and packages from the authenticated sources for installation, upgrade, and removal of packages along with their dependencies. So APT stands for Advanced Packaging Tool. So if you are using Ubuntu based systems, so here the command apt-get can be used. While if you're someone who's using the Red Hat based systems such as the CentOS, so in that case you need to use the command yum. Okay. So the syntax for this command is very simple, like apt-get, the options or the flags and the command. Okay, so say for example, I have to install something on my machine. So I'll use the command sudo apt-get install. Say for example, I want to install this image editor called Pinta. Okay, so I'll just type Pinta, sudo apt-get install and Pinta. Okay, so this was about the apt-get command. The next command is the df command and the disk usage command. The df or the disk free command reports the amount of available disk space being used by the file systems. The du or the disk usage command reports the size of directory trees inclusive of all their contents and the size of individual files. The aim is to make sure you are not overshooting the 80% threshold. If you exceed the threshold, it is time to scale or clean up the mess because you're running out of the resources. So the syntax to use this command, like if you want to see the disk free space in a human readable format, you can use the command df sudo df -h. Okay, so this is the disk free command that we are using, and we can see here the output: size, available size, used, available memory, percentages, and the mounted location. So, but in most cases, you want to check which part of your system is consuming lots of disk space. For the command for doing that is sudo du -h -d 1 and the var. So as you can see here, this location, it is consuming a lot of disk space. So this was about the df and the du command. So now let us talk a bit about shell scripting. So first and foremost question, what is a shell? So an operating system is made up of many components, out of which two are very prime components. And these components are the kernel and the shell. So a kernel is at the nucleus of a computer. It makes the communication between the hardware and the software possible. While the kernel is the innermost part of an operating system, a shell is the outermost one. A shell in a Linux OS takes input from you in the form of commands, processes it, and then gives an output. It is the interface through which a user works on the programs, commands, and scripts. A shell is accessed by a terminal which runs it. So whenever you run the terminal, the shell issues a command prompt where you can type your input, which is then executed when you hit the enter key. So the output or the result is thereafter displayed on the terminal. The shell wraps around the delicate interior of an operating system, thereby protecting it from accidental damage. Hence it is named as shell. So there are two types of shell basically, the Bourne shell and the C shell. So the prompt for the Bourne shell is shown by the dollar symbol, and its derivatives are POSIX, CON, and BASH. POSIX shell is also known as SH, CON shell is also known as SH, and the Bourne again shell is now known as BASH. And the BASH is the most popular shell. The second type of shell is the C shell, and the prompt for this shell is shown by the percentage sign. And there are two subcategories for this, that is the C shell, which is also known as CSH, and the top C shell, which is also known as TCSH. So now the question is, what is shell scripting? So shell scripting is writing a series of commands for the shell to execute. It can combine lengthy and repetitive sequences of commands into a single and a simple script, which can be stored and executed anytime. So this reduces the effort required by the end user. So let us understand the various steps in creating a shell script. So what you do is, first you create a file using the VI editor or any other editor, and you name the script with an extension .sh. So we will also have a look at it, like we will execute a shell script, but I'll just tell you a few steps of how to do it. Then we have to start the script with the symbols such as hash, exclamation mark, and the /bin/sh. So hash exclamation is an operator called the shebang, which directs the script to the interpreter location. So if we use the command hash exclamation mark /bin/sh, the script gets directed to the Bourne shell. Then once we open this file, we have to write some code, we have to save it, and for executing we have to just type the command bash and the file name .sh. I'll just show you how do you do it. Here I have the git terminal or the git bash opened here. So we have to type, say for example, abc.sh. We have to write something here. So what we'll do is, I have a simple program which calculates the sum of the digits of a number. It accepts a number from a user and it calculates the sum of its digits and it displays the result. So this is a very simple program. I'll just write it here. I'll just save it, wq. Okay, so it is saved, and now we have to just run this script using the command bash. Well, let me just check whether I've inserted. Okay, so we are missing out on a very important thing here. We have to type shebang operator. Okay, so hash exclamation /bin/sh. We have written whatever we wanted. Okay, so we have saved it, and now bash abc.sh. So it says enter a number 88. So the sum of digits of 88 is 16. So this is how you write a shell script and you run a shell script. So this was a very simple program, but you can write any program that you want and you can run it using the bash. So we have come to the final part of this session, that is the git commands. And before knowing the git commands, we'll quickly brush up a few things about git. What is git? So git is a free open source distributed version control system tool designed to handle everything from small to very large projects with speed and efficiency. So git has the functionality performance, security, and flexibility that most teams and individual developers need. It also serves as an important distributed version control tool that is used in DevOps. Tools like Git enable the communication between the development and the operations team. So whenever you're developing a large project with a huge number of collaborators, it is very important to have communication between the collaborators while making changes in the project. Commit messages in Git play a very important role in communicating among the team. The bits and pieces that we all deploy lies in the version control system like Git. So to succeed in DevOps, you need to have all the communication in the version control, and hence Git plays a very vital role in succeeding at DevOps. So this was the definition of Git, and this is the diagram that you must remember, like the working directory, the staging area, the local repository, and the remote repository. You just need to remember these things. So if you remember these things, then you will get a clear understanding of what command is used to do what things. So now we will have a look at few of the Git commands. Like as you can see here, we will cover a few commands, git config, git init, and so on, and few of these commands as well. Now let us go to the git bash. So the first command that we will see here is git config command. Okay, so this command sets the author name and the email address respectively to be used with your commits. So how do you do it? The syntax is pretty simple, like git config hyphen global user.name and the name, say for example Edureka. In my case, let's just say Arvind. Okay, this is the syntax that is used, hyphen hyphen global. Previously I just typed a single hyphen. There are two hyphens here. You have registered the username and now you have to register the email. So that is git config hyphen hyphen global user dot email and the email address, that is Arvind edureka.co. Okay, so this works fine. So the next command is the git init command. So this command is used to start a new repository. So this is a very simple command. Simply type git init. Like you can type the name of the repository if you want, else it will initialize an empty repository without any name. Okay, so here as you can see here on desktop, it has created a repository. .git repository has been created on the desktop with our command. So the next command is the git clone command. So this command is used to obtain a repository from an existing URL. Say for example, let me just show you. I'll clone a repository from my GitHub account. Okay, so say for example, this is the repository Game of Life, which is available on my GitHub account. To clone that URL, I'll have to first go to this tab, clone or download, click here, and then you'll get a link. Okay, copy that link, clone with HTTPS. Okay, copy that link and paste it here. Git clone and the repository, paste, press enter. Okay, so the repository is being cloned here and it is still working and it is done. Okay, so as you can see here, the Game of Life repository has been cloned. So this was a very easy command. Let me just clear the terminal. So the next command is the git add command. So this command adds a file to the staging area, and the command for that is very simple: git add and the file name. So this is the syntax for the add command. And suppose if you have more than one file to add to the staging area, you can simply use the star option. Okay, so it will add everything, like more than one file or multiple files. So this was about the git add command. The next command is the git commit command. So this command records or snapshots the file permanently in the version history. So the syntax for this command is git commit -m and any of the message that you want to type. Okay, so with each commit you can type a message to notify. So this is the syntax for this command. Let's just say there's one more command called git commit -a. So there's one more flag with this command -a. So this command commits any files you have added with the git add command and also commits any files you have changed since then. So this is the syntax for this command, git commit -a. Similarly, there's one more command, like as you have seen earlier in the Linux command, the rm command, git rm the file name. Okay. So this command deletes the file from your working directory and stages the deletion. This was very easy command, git rm. Similarly, there's one command called git show, and here you have to specify the commit ID. Okay. So this command shows the metadata and the content changes of the specified commit. So this was about the git show. The next command is the git remote command. So this command is used to connect your local repository to the remote server. So for that, the syntax is very simple. Say for example, git remote, add the variable name and the remote server link. This is the syntax to use the git remote. If you want to delete a branch on your remote repository, so how will you do it? So there's one command called git push origin, the remote server and the branch name. Say for example, B2 is the branch name. So the next command is the git pull command. So this command fetches and merges changes on the remote server to your working directory. So the syntax is pretty simple, git pull and the repository link. So this is a very simple command. The next command that we are going to talk about is the git branch command. This command lists all the local branches in your current repository, and its syntax is very simple, just git and branch. This is a very simple command. And if you want to create a new branch, so for that the command is git branch. Say for example, the new branch that you want to create, so git branch and branch name. And if you want to delete the feature branch, so for that the command is git branch -d and the branch name, say for example B1. So this was the usage of the git branch command. The next command is the git checkout. So this command is used to switch from one branch to another branch, and the syntax also is very simple, git checkout and the branch name where you want to switch. Okay, say for example B1 or B2 or even master. So this is one use of checkout. So if you want to create a new branch and you want to switch to that branch, so for that the syntax is git checkout -b and the branch name B4. So this command creates a branch and also switches to that branch. There's one more command called git merge. So what this command does is, this command merges the specified branch history into the current branch, and the syntax for that is git merge and the branch name, branch_name. So this is a very simple command, like git merge and the branch name. There's one last command that we will have a look at, that is git rebase. So what this command does is, this command will move all your work from your current branch to the master branch. They look like as if they are developed sequentially, but they are developed parallelly. So the syntax for rebase is git rebase and the branch name. So this was the syntax for git rebase.
So the objectives of the create user logins and give them the access accordingly. Run commands from super user, getting elevated permissions, manage permissions for files and directories, and modify and add user permissions and user groups. So let's start user administration. First of all, users in Linux. A user is anyone who uses a computer. The system has a name for each account it creates. For example, we have seen in previous slides and videos that I have in my system have created a username with Vikas name. So every user has got its own name. System has a name for each account it creates, and it is the name by which person gains access to use it. Linux supports multiple users to be logged in the system. Managing user is done for the purpose of security by limiting access in certain specific ways. A user or account of a system is uniquely identified by a numerical number called UID, and there are some reserved names which may not be used, such as root. So by default, in any Linux distribution, root is the name which is already present in the system. You cannot create a new user with root name. So let's come to the user configuration part. As we have discussed, one can create multiple accounts for logging in the Linux. Each user have different privileges. The user having the highest authority can restrict the other user to add new users or the data he has access to. So for example, if someone has access to root user, and if I am access to some another user of some another group, the root user has privilege to stop me from accessing some files. By default, one account named root has access to all the files and perform every action. So where user information is being stored? So actually there are three files. If you create any system and go on writing password command, PASSWD, it will prompt you for entering a new password and re-enter a new password. It will change your password. So what it does is, whenever you run this command, it stores the user account information for the system. Actually, it binds it to another folder which is named as etc which stores the password for various accounts, and by default it is not accessible to anyone except root user. So if I am a user called Vikas and I want to access etc shadow, it won't be accessible to me. Yes, etc password will be accessible to me. I can change my password, but I can't access etc shadow file. Then comes etc group. So every user is made up of some group. So there's a hierarchy, like there are groups, and in the group there are different users. So in etc group, it contains the different groups of the system. So if we go to etc password file, we will see something like this as an output. So what it suggests over here is, if we see line number 10 or line number 11, the first line is the username. So the first username might be polydate and the second username is Ubuntu. The second line is password, which is not being shown over here. It is being moved to etc shadow file and it will be only visible to root user. Then the third one is user ID. So every user has got its own user ID, which is mapped to some of the group. So we can see by default the root group has group ID equals to 1, and root has got user ID as equals to 1. So if you create a new user in the group of root, it will have the elevated access of root user because it is of group root, but it will have different user ID. Similarly, we have seen over here the group ID is 1, which is of root, but the user ID is 111. But for the Ubuntu case, the group ID is different. So Ubuntu has got different group ID than root. It is not the root, which is the group for Ubuntu. Also, the user ID is different. Then the home directory. For Ubuntu, the home directory is home Ubuntu. For Pollinate, the home directory is var cache pollinate. And the default bash. So as we have seen, the default shell script these days, which is the most popular one, is bin bash. So default bash is bin bash. Now getting to the shadow file. So the same password which was there, same user which was there in password file, the same one is here with the name of Ubuntu. This is the password which is in encrypted form. Then comes the time, which is in UTC, which is last modified time. Then it suggests minimum days before password can be changed. By default, there is no expiry or no promption to change your password in any Ubuntu machine. Maximum days, that's why minimum days before password can be changed is shown as 0. Similarly, maximum days before password must be changes a very huge number, that is 9,999 days. Then warning days before password expiration is 7, but it is of no use because there is no minimum days before password expiration. So let's talk about super user. Super user is commonly known as root, which has got a user ID of 0 and group ID of 0. So it is by default created. Any machine which is any Linux distribution which has been created has got its user as root. It doesn't have a password by default. One can assign it by command as sudo password root. So what happens is, whenever you do sudo -i, it never asks you for the password of root. It always asks you for the password of your own username. Even if they are giving you the elevated permissions of root user, because root user doesn't have any password by default, they don't ask you the password of root. The Ubuntu asks you the password of your own user. It is advisable that you give a strong password for root. One should only use this privilege for small interval of for specific task and then go back to normal user because it is a security breach. Once someone has got access to root user, he can do anything with the machine. Inexperienced user can cause serious harm to OS and may also leave security vulnerability if they have got access to root user. Then how to switch user? So for example, I'm a user with the username of Ubuntu. How shall I change my user account? So if username not provided, it takes root by default. Once command is given, it asks for the password of the user. If correct password is provided, it opens the cell for that user. Otherwise, it exits and return to the original user. For example, I have logged into my machine with the Vikas username. Then I go to sudo command and I don't write anything. I just do sudo. It will automatically redirect me to the root user. And if I do sudo Ubuntu, then it will redirect me to the Ubuntu user and then it will ask the password of the Ubuntu user. Root doesn't require the password to switch to other users. So if you are in root, you are the super user. You don't need any permission to jump to any other user. Sudo. Adding sudo runs command with user privileges. So by default, it is root if user is not mentioned, as we already discussed. So if you are just prepending sudo command over any of the commands. So for example, if I'm creating a directory mkdir edureka and I'm not giving sudo, it may not have the permission to create a directory in root folder. But if I provide sudo and prepend sudo over mkdir, it will be able to create folder into the root folder also. So permissions for sudo access is stored in etc sudoers. By default, new added user don't have sudo permissions. So for that also, there are scripts, there are lines that for all any new upcoming user, we can guarantee it that it gets the sudo access. If it is not, if you don't want that, if you want to provide it after you are adding user, you can use this command sudo gpassword -a student sudo. So what it will do is it will grant access to the user's student of the command sudo. So let's check it. So right now I am logged in with some user Vikas. So if I go to who am I, it will be Vikas. And if I go to etc password, I go for win, it is showing. But if I go for shadow, it gives me an error, permission denied in the last line. You can see that. Now what I will do is I will give it sudo vim etc shadow because passwords are really being stored in shadow. It asks me for the password of Vikas. I go for abc and now I can see the file shadow. So that's how sudo works. Now let's see how to add a new user. So user add is the command. So for example, I have to create an, let's take this as an input, sudo user add student, and then configure it. So we are seeing over here is that previously I ran tail command and I just wanted the last two lines of etc password find. What it gives me was there was a bind user and stu user. Now ran that command user add student. Now if I ran the same command again, the last two lines of etc password, I can see there is a new line student which has got new user ID, new group ID, new home of itself. So this is the example how you can use user add command. Simply do user add and username. Just prepend sudo over it if you are not logged in as root user. Always prepend sudo over it. So if I want, because what happens generally is if I add a user, suppose it to be xyz. So if I'm doing sudo user add -m xyz, what it will do is it will create a folder of home xyz by default. In home, it will be given the same folder name, which is the name of the user. But if we want to give it a predefined home directory, we can give option as -d and then provide the predefined directory name if there's already one directory existing over there. If I want to create a user with expiry date that after this date the user expires and has got no rights on the system, I can provide it with -e command. So there are options for user add. -c includes user full name, -e date when the user account will be disabled, -g specifies user's default group, so I can create a user with default group as root. Capital -g specifies which groups to add user to. So if I have got a previous group of Ubuntu or a student, I can provide user add -g and then group name. -m specifies the user's home directory. -d specifies the predefined directory of the user, which we have already seen. -p specifies user's password. So we will be creating a user's password if we will be adding user add -p also. And then -s specifies the default shell for the user, which is bin bash. So delete a user, just like user add, for deleting user there is user del. So it's kind of same. Right now what we have seen is, if we have ran tail -2 command, we can see previous student was there and there is a new user1 with UID 1004 and GU group ID 1004, home directory user1. Now the system has deleted user del student. Then we are back again to the original stage where we used to have stu and now user1, which is newly added. But the student which we added now is being deleted. How to modify a user? So things which you want to modify in user. So want to modify the expiration time of the user. I would want to modify password of the user. So these are the basic things which you want to change even after creating a user. So to assign a password, what you have to do is, just like root, which we did sudo password root, you have to give sudo password Vikas or sudo password Ubuntu or sudo password student. It will prompt you for the username, new password, and assign the new password. Use commands to modify the configuration. Sudo user mod, so it will modify the user. And then the different options. For example, if you want to modify date when it will be disabled, so we have seen that -e is there. For group, -g is there. For home directory, -m is there. So we can also do that. We can use user mod -p and change the password, user mod -g and change the group. So these things are also possible. Now, whenever you are giving a password, what we saw in the earlier stage was minimum days to change the password was 0 and maximum days to change the password was 99,999. So there was no way that password was aging. So we have got password aging policies too. Just for being on the better side of security, it is advisable to change your password time to time. So what command we use over here is chas. It changes the age of the user. So chas command on Linux changes the password related information. The information is used by the system to determine when a user must change his or her password. So for example, if I write change student or change user1 or change Ubuntu, chage Ubuntu, what it will give me, it will give me a prompt where it will ask me minimum days to change the password. If I specify it as 10, so maximum days, it will re-ask these questions because these questions were never asked to me prior to this. If I use command like chas, it will ask me minimum days to change the username password, maximum days to change the username's password, and also it will ask me since which day I will love to have the notification that your password is expiring, please change the password. So the option for chas is set minimum number of days before password change, set maximum number of days before password change. So if I don't provide a minimum number of age and I provide maximum number of age, after that age it will be obviously deleted. So account aging information, if there's any account aging information, just give -l command without any space and set password inactive after expiration, minus for the hyphen space l. If you want to set an expiration date, don't want to specify days, in how many days you want to expire it. If you want to give the exact date, -e is the option, and set the last date of the password change, -d is the option. So let's check the demo. So what it suggests is chas -l. It lists down everything. So what is the scenario right now? For example, if I run the same command in my system, if I do chage, so what I've done is I have listed the current status of the user Vikas. So it says the last password change was done on September 21st, 2019. The password expires never. Password gets inactive never. Account expires never. Maximum number of days between password changes. Minimum number is 0. Maximum is 99,999 days. So it is basically never. If I want to change it, what I have to do is just give chage and username. What it has given is permission denied. Now let's do with sudo. Now if I start with sudo, it asks me the minimum password age. So I'm again specifying it as 0 because I don't want to do it. 99999. Last password date change was, let me do it 2018. This I can change because it won't hurt me anyway. Expiration date I want to change it to 14. Password inactive, let it be default. Account expiration, let it be default. And now let's run that command again. So what's seen the change over here is last password reset change was previously September 21st. Now it is September 22nd, which I have changed, and number of days expiration of warning before expiration is 14. So this is how you can change things with chas command. So let's get back. Group management. So every user is associated to some group. As we have seen, every user id is associated with some of the group id. So Linux group is the mechanism to organize a collection of users. Each group is associated with unique id called the group id, which we have seen in etc password folder. There are two types of group, a primary group and a supplementary group. Each user is a member of a primary group and of zero or more than zero supplementary group. Users may be added to an existing group to utilize the privilege access it grants. So for example, if I want to escalate the permissions for any user, what I will do is I will give it the access to the root group ID to the same user. I can do user mod, and by -G option, I can provide the group ID as root. Every user by default gets its own group unless restricted manually. So if I create any user Vikas, it will be getting a group name of Vikas only. So user groups, the group details are defined in etc group file. By default, every group user gets its own group. So I'm talking about student, it will be of student username only. Then comes if I want to create a new group. So like user add, there is again a command group add. Similarly, like user add. So a new group can be created and user can be made part of it. A command changes the value in the file etc login.defs. The default ID for minimum group ID is 1000. Group ID starts from here. So apart from root group ID, which is 0, all the group ID starts from 1000. So you'll be seeing group ID as 1001, 1002, 1003, and so on. There is no limit on number of the users in a group. So you can have n numbers of users in a group. So command is simple, sudo group add, group name. -F, then again options. -F, exit successfully if the group already exists. -G, use group ID for the new group. If I don't want any default group ID to be associated with it, like 1001 or 1002, I want it to be given a group ID of 5001. So I can use -G command and give it the group ID as 5001. -P uses this password for the new group. So any user which wants to associate with this new group will have to insert the same password. -K overwrites the etc login defs, which is the default login for the group. And again, similarly like user mod, there's command group mod, which is for group modification. We will need to modify the users accessing the group or group details based on our requirements. When the maximum limit is reached, a new group entry line is started in etc group. The command modifies the value in etc login.defs. So group mod exit values are 0 for success, 2 for invalid commands in text, 3 for invalid argument to options, 4 specified group doesn't exist, 9 group name already in use, 10 can't update the group. So again, the group mod, what are the changes which you can make in a group? You can change the group ID, you can change the group password, you can add a user account to this group, you can remove a user from this group, and you can also change the name of the group. So just like user del for deletion of group, there's again group del. So we may delete a group if it is not required anymore. We must delete the user before deleting the primary group for it. Otherwise, it will be in dying stage. So let's talk about ownership and permission. So we have heard a lot about permissions. Read, write, execute permission. We have been seeing that there are things like W, R, X. So W is for read, R is for write, X is for execute. So read has got, because everything is in binary, read has got 4, write has got value 2, and execute has got value 1. That's why it is always decided whenever you are running a shell script, you give the user mod as 755 so that only you, the 7 is the permission for read plus write plus execute. So only you have the permission to read plus write plus execute. For the next 5, 7 is the permission for you, 5 is for the group. So any other user of the group is able to read your file and execute your file, is unable to write or make changes in your file. That's why we are always giving 755 access rather than 777. So permission for a file or folder. The set of permission for a file or folder is in 3 categories. So the 3 categories are user groups. So the example what we just discussed was 7555 abc.txt. So if I'm giving access of 7555 to abc.txt, which means user has got an access of 7, the group of that user has got an access of 5, and others have got an access of 5. So what are users, what are groups, and what are others? So user is the person who has created that file. Group is the group in which the person is associated. There might be more than one user of that group. If the user is of same group, he will again have the access to read and execute the shell script. And if I give a permission of 754, then others would be giving only the permission to read. So anyone who is not from the same group or same username will be having access to just read the files, not even execute it. So this is the permission. 1 is for execute, 2 is for write, 3 is for write and execute. So this is binary cohesion. As we have seen over here, these the file type, that is directory of Ubuntu. RWX is read, write, execute, that is 7. And then XR is group permission. So it has got permission, the same group, Ubuntu group has got permission to execute and read. And any other user who's not from the same group has not even got permission to read the file, has got permission only to execute the file. So they are not able to get the source code. So default permission for a file is 664, while it is 775 for a directory. So 664 means all the file has got a permission to read, write, and read. That means none of the file has got a permission to execute. You can change it by setting the unmask value for the user. To check current unmasked value, use command umask. It shows the total octal value. A file gets a permission of default base value 666. Unmasked value and folder gets permission of default base 777. Now changing ownership. So we have seen three things: owner of the file, group of the file, and then others. So if you want to change the owner of a file, what you have to do is run chown command and then give the username. For example, there was a file called abc.txt which was previously associated to some user called Ubuntu. Now I want to change that. I have to change that. I will do chown vikas file name abc.txt. So the file which was there for Ubuntu user will now be owned by the username Vikas. Similarly, the same thing can be done for the group too. Chgroup change. Ownership of a file is specified in the specific format. User, user group, user, colon. User is the name of the user to own this file, user group, the user and the group to own the file separated by a semicolon. Only group gives you the group to own the file, user is removed from here. User is the owner, changed to the user, and owning the group is login group of user. Options for chown, again, -C displays the information of file which is changed. -F does not displays output. -R operates on file and directories recursively. -H if the file system is symbolic link, traverse it, open, operate on the files and directories. So if I check ls-ltr command, I can see that there are root users for every directory over there in the system is having username as root and file as roots, even hello.txt. So what it has done in the next command, the owner of the hello.txt has been changed to Ubuntu. Now the group ID has not been changed. The group has not been changed. So group is still root group, but the user is now Ubuntu. So this is how you can change the owner of the file. Then chmod, if you want to change the permission of the file, like over here, we have got permission on hello.txt as read, write, read and read. There is no execute permission to hello.txt. If you want to give it a hello.txt the permission, what we have to do is chmod 744. So what will happen is 7 indicates read, write, execute. So it will be RWXRR. So this is what chmod does. It changes the permission. Options for the chmod again, -F it suppresses the error messages, -R it changes files and directory recursively. If I have to give a permission to whole directory recursively and the same permission should go on all the files, then we can use -R command. Then -C output diagnostic message for change in every file made. So all the file which will be changed will be shown over here if you use -C command. So let's see the example for chmod. So the command is ls-ltr again, and we can see that there's a file called hello.txt. The hello.txt has got permission of read, write, execute, and read. So what we have done is we have done cat hello.txt. So this is a hello file. That was the content of that file. Now I'm changing the user permission for that file. It is 222. So 2 is write. So I'm giving a write permission to everyone, but not read permission to anyone. So if someone wants to open this file now, hello.txt, it says permission denied. And again, and if I check the status of hello.txt, it has only got www. There is no read, no execute. Again, chmod 7555, it starts opening. Now it will be having rwx, rx. Now let's talk about special permissions. So special permissions is SUID. We have talked about UID in the start of the class. So if a file has to be executed only as a particular user, then instead of modifying the permission for another user every time, we can modify it always run like it has been run by that user. So the fourth line in chmod, the first character in chmod 4664 file name, the first character 4 is the SUID. Example, password command which changes our password has only got root access but still works for other users because it is always executed as root is executing it, because we have seen that etc password was getting opened even I was there in the user ID Vikas. etc shadow was not opening, etc password was being opened. Why it is being opened? The reason behind it was SUID. So if you change the mod to something like 4664, what it tends to give is it will always open this file as some pseudo user. So SUID is pseudo user ID. Similar is the case for pseudo group ID. SGID is again the same. So for SGID, again the line is 4. SGID has got the representation of 4. So if we want to merge SUID and SGID, what we can do is, actually SGID has got the representation of 2 because 010 is 2, 001 is 1, 010 is 2, 100 is 4. So SGID has got a representation of 4, and if we combine 4 and 2 it is 6. So if 110, so if we give a chmod of 6664, then we can merge SUID and SGID. Now let's talk about sticky bit. It is primarily used in shared directories. So for example, it is useful for directories like temp, where user can't delete a file created by another user, even though temp has 777 permission. So if everyone has got access on temp folder. So if I'm writing some files, for example, TCP dump is running. TCP dump is an application in Linux which monitors your network and which checks the traffic inflow and outflow in network. So when I'm running any TCP dump, it stores all the packets in the temp folder. And if someone starts deleting it at the same time, it will be an issue. So we assign a sticky bit to it. So rather than giving 6664 or anything like that, if I assign chmod 16664, only root user has permission to delete that file. Then comes the concept of access control list. So we have been studying about user permissions for the users who are in the same user ID or same group. But what if the user ID is not in the same group? User is not of the same user ID or not of the same group. Then ACL comes into picture. It allows permission to user or group even if they are not part of owner or owner group. So in that scenario, we can give the access control list to them. How it is done? Set f, setting ACL for file, set f ACL minus m, the use my group name, first name is user, username is user, group name is student. So using the username user and group name student, I'm giving read write execute access to file.txt. And if I check get facl, it will give me the same. For example, get facl file.txt. So the file is file.txt, owner is Ubuntu, group is Ubuntu. Owner has got read write permission, group has got read write permission. Now there's nowhere anyone with the name of user or anyone with a group of student mentioned in this control list. But what we are giving it, we are setting an access control list, giving the user ID as user and group ID group as student, giving it read write execute permissions. Now let's get facl file.txt. What we have right now is user has got read write permission, but when user with group name student is there, you have got read write execute permission. So we are masking a read write execute permission over here. Now let's talk about hidden files. So there are many files which are hidden in Linux, like basrc, vimrc. If you are using Vim editor, it has got its own RC file, basrc, rclocal.d. So these are hidden files. So any file which starts with dot is a hidden file. So if you have to create any hidden file, just use dot before your file name. So if your file has got name as abc.txt, use .abc.txt, and whenever you run command as ls, you will never be able to find that file abc.txt until unless you run the command as ls-a. Then all the hidden files are also shown. So for example, ls-ltr we have done. We are just seeing link directory student dir new.txt and hello.txt. But when I appended a in that ls-ltra, we can see there are hidden directories and hidden files. Hidden file is .file.txt, the hidden directory is simply dot and dot dot. Now to check the authenticity of any file, there are some ways like checksum, md5 sum. They have given a specific hash value to every file, and to check that the integrity of the file is still maintained, we can assure by md5 sum. So md5 sum is to verify the integrity of files, as any change to a file will change its md5 hash value. So if I'm writing a file with the name my name is Vikas, everything is small, and I just change the first letter my from small to capital, checksum will be changed, and this is how we will get to know that this file has been modified. So to check whether the file has been modified across the networks when it was shared, it is always advisable to use MD5. We'll learn about bootloaders and package management. Now let's talk about RPM. So the full form of the RPM is Red Hat Package Manager. The files used by this program have an extension of .rpm. RPM was originally created in 1997. It is free and released under GPL license. It is default packaging for distribution which comes under RHEL, CentOS, Fedora, etc. So to maintain packages, by maintaining I mean adding, updating, deleting packages in RHEL, CentOS or Fedora, we use RPM. So if you want to install any package in CentOS, there are commands like rpm-ivh, then the name of the RPM. For example, if you've got MySQL RPM with version 5.7, so let us suppose the name of the MySQL RPM is mysql.5.7.rpm. So this is just the pseudonym which I'm creating right now. So what you have to do is rpm-ivh and then the name of the RPM file, mysql.5.7.rpm. It will install your package. So let's check out the features first. First feature is crypto. The packages in RPM can be verified cryptographically by MD5 checksum and GPG key. So to check the integrity of any file, we have got MD5 sum. So to verify that package has not been changed from the source to a machine, we use MD5. And then to authenticate that whether it is from correct source and there's no one behind the source and IP spoofing it and getting into your system, you need GPG key. So you take a GPG key from that machine, then install it. Authentication. Source archives is also available, which helps in authentication. So RPM helps in patches also. Patches can be applied, which helps in updating the process faster and easier. So if you have patches, you don't have to reinstall your system. You just have to change some few files and just rebuild it, restart it. It's not that you're again going to compile your whole program and then going to restart. It is automated and installation time verification. It is done for the dependencies, like if I have got a package and it is dependent on 15 or 20 different other packages. So it asks you to download them to carry on with the installation of your current package. So the basic tasks for RPM, so it is the basic task for any package manager: installation, updation, uninstallation, query, and authentication. So we need to check how to install a particular package, how to update an existing package, how to remove the currently installed package, get information about the package, what is the version which it is using, things which it depends on, and then authentication to verify the package for the security reasons that the package is from authenticated source. Red Hat developed RPM packages can be found at Red Hat Enterprise Linux CD-ROMs, Red Hat Network, or Red Hat errata page having list of packages. So if we go to any of this link on internet, I'm just going over there and I'm going to search MySQL. So it gives me all the versions of the MySQL. So it suggests that it has found 95 RPMs, very old ones, 5.0 since 2009. So we can see there are the packages, MySQL client programs and shared libraries for 64-bit machines. This one is for 32-bit machine. i386 or i686. x86-64 is for 64-bit architectured machines. So there are different RPMs for different machines. Now how to install? So to install, -I is the option, but we probably go for V also because it is the verbose mode and it suggests that okay, something is going on, because if you just install any RPM package with RPM -I, it will be installing it, but there will be no status bar in it that okay, 100%, this is now 10%, 20%, 50%, 100%. So to get that feel that okay, your software is being updated or software is being installed, use verbose also, and then print hash marks of the package archive as it is unpacked. We use -h. Usually we use rpm -ivh. Now check the rpm signature. To check the signature, we have this command --check sig. So it checks the PGP signature before installing any package. If its integrity and origin is okay, because at the background it checks for your MD5 sum as well as your GPG key. So if integrity and origin is okay, then one can go ahead and install that package. If you have any query on that package, -q is the option. So it is pretty straightforward till now. If you want to have a query on package, it's -q. If you want to install, that's a little bit different when you want to uninstall a package. It is like eradicate -e, so we will come up to that. It checks the dependencies of the package, if package is dependent on some other packages. To ignore these dependencies, use --nodeps. So rpm -q --nodeps and the package name. One can check if a particular package is already installed or not. To do that, just add -l. So -l is for list all the installed packages. So if it is installed, rpm -ql. Now to install all the packages which are there, to view all the installed packages, use -command. So rpm -qa. So one can list all the recently installed RPM packages. One can shorten the list to check for recently installed by adding --last, which will return the last package installed on the machine. Upgrade a package, you need to do it -u. RPM -uvh, V is again for verbose and H for hash. So RPM -uvh, and then your package will be upgraded. Now to remove a package, as we have discussed, it is -e rather than -r or -uninstall. So it is like eradicate. To remove a package, use -e option. In case you don't want to remove the dependent packages, you just want to remove your package, then apply --nodeps in it. To find the package to which particular file belongs to, use -f in your query. So f will give you file name. To find the details about a particular installed package, again rpm -2i and the package name. To verify an RPM package, use -V option, because small v is for verbose, so use -V option. RPM-V P and package name will give you the verification of the package. So to verify all the packages, use A. Rather than P, just remove P because P is for specific package name. If you go for A, it will verify all the packages in the system. So this RPM demo can be done on CentOS or Fedora machine. Right now in our setup, you're using Ubuntu. So let's check it out how it is being done. So if I'm going to install RPM -ivh, you can see those hashtags coming. So if you're not using -vh in there or h is in there, these will not be coming. To verify whether a package is there in the files or not, just use rpm -verify. To query on a particular package, that what are the things which are there in the package, rpm -ql httpd. So we know that httpd is there for hosting web servers. So this is, if you go to etc folder, this is how it looks when it is being installed. So it gives you all the files which is packaged in the rpm folder and inside any rpm. Now let's talk about yum. So rpm was the package manager. Yum is again another which is being used in the free versions of the CentOS. So if you don't have that .rpm files and you want to install from the source repository, which you are not, because in rpm files you need to have that .rpm downloaded. If you don't want to download .rpm, you don't want to take that headache of downloading .rpm from internet, what you can use is you can use yum. So yum was created in 2003 and is primary choice for RPM based distros. So wherever we are using RPM based distros like CentOS, Fedora, Yum is the repository for it. We tend to do in Yum is we just write the package name which we understand. So I don't know the version of MySQL. I just go for yum install MySQL. It will search whether MySQL is there in the repository. It will come up with a specific version number. It will suggest, okay, it is there. Install it via this command. When you do that, you don't know where that RPM package is kept or whether even RPM package is kept or not. It automatically downloads that package and installs it. So installing and updating the packages are simpler. Software dependencies are taken care of and installed along with it, because if we are using RPM package, we have to install all those dependencies by ourselves. But in Yum, it is just like apt-get, it will install all those dependencies. So we have two things, RPM and Yum. The same thing which RPM and Yum is almost synonym to dpkg and apt-get. So if you want any package to be installed manually in Ubuntu or any Debian Linux Debian distro, what we tend to do is we use dpkg command to install it, and the extension of the file is .deb. Similar to what we have in CentOS, where we use the same mechanism. We use rpm-ibh, and the extension of the file is .rpm. And in the same way, the Yum has replaced RPM to some extent. apt-get has replaced dpkg to some extent. So let's talk about Yum first. Software dependencies are taken care of and installed along with it. Yum is primarily in command line interface, but GUI-based wrappers also exist, but it is pretty simple in command line interface. It's easy to use in command line interface. It is the official package manager of Red Hat and CentOS. So RPM is there, but this is the official package manager. This is the package manager. So RPM and Yum. RPM is the package manager which installs the package, while Yum is the repository management tool which will fetch the package. So to get MySQL installed, you need to find it on internet where you can get .rpm files. But if you want to install it via Yum, you don't need file. Go yourself, take the pain by yourself and search it on internet where the .rpm file is, download it and then install it. So you don't need to do that in Yum. In Yum, you just need to list the files, okay, whether it is listed or not. If it is there in the source repository, you can install it. And you don't need to know what was the source of it, where it has installed. That headache is of Yum repository. Yum fetches appropriate package as required by our Linux, which is compatible with our Linux. In RPM, it can be that I have like in CentOS 7, the default Python version is 2.7. But by mistake, I go and I don't use Yum. I install it via RPM and install Python version 2.4, which is a very old version. So it is not compatible. So to not to take care, which is not to take headache of what is the compatible version of the software with this Linux distro, it is advisable to use the repository manager. RPM can alert you to dependencies, but is unable to source additional packages. So in RPM, it will check these are the dependencies which need to be taken care of. It will invoke a alert to you that you need to install these packages first, but it will not give you the source directory or source from where to get these services or these packages. But Yum finds out all the dependencies and also the additional packages and installs them if you're installing any package via Yum. Yum by default has multiple repository location in its configuration file, and it fetches packages for installation. So how to install using Yum? Use command install to install a package using Yum. So if I need to install anything, just do yum install Python. I don't need to give the version of it. If I'm going to use 2.4, 2.6, like by default in CentOS 5, 2.4 was there. By default, 2.6 was there in CentOS 6. Now in CentOS 7, it is 2.7. But if you want to go for 3.5, 3.6 or 3.7 of version of Python, you need RPM for that. But via Yum repository, or you need to tweak Yum repository a bit. You need to go to the Yum source repository.d and then tweak over there. So the first syntax is yum install Python. It will ask you if you are interested to install this package or not. Just question on it. If you don't want, if you are writing a shell script and you want it to be installed by itself, just insert -y command. The same thing happens with apt-get 2, same thing happens with yum2. Yum-y install package name Python. It will be installed and it will suppress the confirmation question, and it will take the input as yes, that okay, yes has been already been provided, install that automatically. To remove, yum remove package name, and again to provide confirmation and suppress the confirmation and automatically do is it yum-y. Then list package names. So if you want to check whether a specific package is there in the source repository or not, yum list any specific package name. So it is checking for OpenSSH server, which is my SSH server, which listens on port 22. And if you want to connect from one machine to another, there is a service called user bin SSH daemon. So that enables you to SSH from one machine to another machine, which we just had an example of SSH username at the rate your machine IP. So that's the package we are searching for, yum list OpenSSH. So to list all the available packages installed, use installed keyword yum list installed. And if you want to check all the packages which are there in yum repository, just write down yum list. Use command. If you want to search any package, use command search to find all available packages to match the name of package specified. If I don't know the exact version of it or exact name of it, yum search SSH or OpenSSH, anything. So it provides the exact package name which needs to be installed. To find which package provides a particular file, because if you are seeing some file in a system which you haven't created and it is there by some package, you can search the originator package for the file name using command yum provides file name. Again, for updating any specific package, for right now I am using Python 2.6, I want to update to Python 2.7, yum update package name. If that update is available there, it will update it automatically. And to check update for which packages are available, you can write command yum check update. If you want to update the whole system, just like Ubuntu apt-get update and apt-get upgrade was there, yum update is there and sent to us. To list all the enabled repository in yum, we use command repo list. So to check what are the repositories which are there in my yum source directory, yum repo list. To view both enabled and disabled one, because few repositories are commented. So to check all those, yum list all. To install a specific repository, yum ---- enable repo, the repository name which was disabled. So enable that repo and that package name. So to view all those commands, the other few commands in yum are yum history. Check what are the things which you have executed in yum previously. Yum clean all, so it removes all the cassette packages and header created to resolve the dependencies. Yum group list, which lists yum groups, group info, group install, and then group remove. Demo about the yum commands which we have just gone through. So we have searched, we have checked that to list a package, it was the command yum list. So we are just listing the package with yum list OpenSSH. Now it is going for all the packages, all the repository it has. Probably it is going to FTP server of IIT Madras. So ftp.iitm.ac.in, and from there it is checking for the OpenSSH. Update a package. So again, yum update OpenSSH was there. So if there is any update available as per the source repository, it will update it. Install a package. This is a pretty cool package in Linux Wine. It enables you to run all those executables of C of Windows machines. So if you are FIFA fan or NFS fan, so you won't be able to get those things on Linux distributions, because FIFA or NFS doesn't support Linux distributions. So if you want to run Linux distribution too, you just need to install Wine. The Wine application enables you to run EXEs also. So actually, these Windows files are executable formats, EXE format. So Wine enables you to run your EXE files. So what it has done is yum install Wine, and then it will be installed. So right now, yum history tells you about what are the things which have been done in last few time. So it says that yum history has got 34 commands in it. Last one was install libx11 development package, and before that it was update. So actions is also defined, date and time is also defined. Now how to search for a package. So it is yum search OpenSSH, which it has been done. It is now searching for the package. What are the packages available with the name OpenSSH? You can see there are many different packages which are available for OpenSSH. Choose any one of them. OpenSSH server, OpenSSH client, LDAP, GSI based, Perl based, anything which you want. If you just want to OpenSSH server on your machine, install using OpenSSH server x86-64. Now let's get back to DPKG, Debian packages. DPKG is the main package management system in Debian and similar OSs. It is used to install, build, remove, and manage packages. Package for it has an extension of deb at the end. DPKG is low-level tool. apt is commonly used as high-level tool as it can deal with complex tasks involved in package management. The DPKG database is located under var lib DPKG. So DPKG is almost similar to what RPM is there in CentOS, and yum is similar to what is apt-get is there in Ubuntu. So how to install? Again, just like RPM, we used to install via rpm-i. So similarly, dpkg-i package name. So if I have that Debian package with me, like if I need to do any installation via RPM, I need to have that RPM package. So similarly, I need to have the Debian package to be installed by dpkg. So I'm installing Python 2.7 Debian. So dpkg-i Python 2.7 deb. So to check whether your dpkg Debian package has been installed or not, you can use command dpkg-s python. It will check if the package is installed, and if it is installed, it will return. Again, to list package, dpkg-l package name. If you want to list all the packages, don't add the package name. If you just want the content which is being used in Python 2.7 Debian file, like the last time which we saw for HTTPD, we list all the file names of HTTPD. Similarly, over here, we did that with rpm-qf. Now, in this scenario, we can do it with dpkg-c. To remove a package, just like in RPM we did by rpm-e, we have got dpkg-r, the package name. And now it is not required to give the Debian extension of it. Now, installing the packages from the directory itself. So if we need to install all the packages which are there in the directory, -r, because it will install all the packages recursively. So use command -r and then -- install and the directory name. So it will install all the packages which are there in the directory. So if you've got 15 packages which you need to install, you can do this. You can put all those 15 packages in the directory and then install recursively using directory. You don't need to give name of each and every package at the time of the installation. Now to update a package, like if we have to update Python, you need to do dpkg-u and specific package name. Now let's check the demo. So dpkg-s python. Now let's check dpkg-s python. So it suggests Python is not installed and has got no information on it because this file has not been installed using Debian package. If I ask apt to install Python for me, it will check and install the Python version 2.7. Now I have installed Python 2.7. It is unpacking and linking all those libraries and processing things up for me. Now let's do Python dpkg. The thing which I have done is dpkg-s python. Now it suggests package name is Python. Status installed, okay installed. Priority is optional. It gives all the information about the package. I have done dpkg because I don't have the Debian package right now with me. So now dpkg-l python. Let's run this command and check what does it give. So it gives me the Python version of 2.7.15. Now let's get to apt, because you would be using apt package manager very frequently rather than using dpkg. apt-get is the command line interface to handle package using apt library. Just like the yum library we used to have sent to us, we have got apt library in Debian based distros, Linux distros. It is the default package management system for Debian like distros like Ubuntu. It is an efficient way of handling packages in your system rather than using dpkg. It is advisable to use apt because dependencies are managed automatically. Upgrades and removals are handled carefully to maintain the stability of the system, and it has an external UI support with tools like Synaptic, Aptitude. But right now we are not using any tool like Synaptic or Aptitude. We are going via command line interface. Now let's understand few commands first. apt cache. apt cache is a command line interface to search for apt software packages. This tool is used to search software packages and get information about them. One can search for a package without having exact name of the package. If you even have some pattern of it, you can get it from the apt cache. The data is fetched from different sources listed in sources.list file. So as we saw in yum repo list was there. Similarly, we have apt-get source list over here. So it has got a number of links from where it searches for its packages and installs it. Where cache apt archives contains already downloaded packages to avoid downloading them again if one needs to reinstall a package after removing it. So now uses of some of the apt cache commands. How to list and search a package using apt cache. Use command package names to list packages starting with particular string. So example, if you just want to search all the packages which are starting with open, might it be open SSL, might it be open SSH, anything. What you need to do is apt cache package names and open SSL or Python, anything. So that will fetch all the package names. You search for a package with a particular name. Apt cache search Python. Use command show to get details about a package. If I want to get all the details about specific package, I would use apt cache show Python. Check the dependency of a package. Like if I install Python, what are the other packages which will be installed, which are required in support of Python to enable Python to run what are the other packages which are required to run. We can get that via apt cache show package Python. Now to update a package, use apt-get update specific package name. So if you are to update Python, we would be using apt-get update Python. If we have to update the whole system, apt-get update simple. And then if we want to install a package but prevent from upgrading, if already installed, use minus minus no upgrade options. Now to install a package, apt-get install package name. It was for updation. Now let's go how to install a package. Rather than using update, just use apt-get install package name. If you want to install multiple packages, apt-get install multiple packages, Python, MySQL, OpenSSH, anything. And again, you might need to provide -y with it. In some of the previous version, like in 16.04, it used to ask for the confirmation. To install multiple packages having a particular string, use wildcard. So all the packages in the source.list which is having star name as regular expression in it, it will install all those packages. Now apt-get upgrade. If you want to upgrade the system, you can use command apt-get upgrade. It may remove or update some of your installed packages. If you want to upgrade only some specific package of your system, you can use apt-get install Python. Minus minus will only upgrade Python. It will not upgrade its dependent packages. Now, if you want to remove, apt-get remove specific package name. If you want to remove all the configuration files associated with it, what apt does is apt stores the configuration file, because in future if you reinstall the package, you don't have to take care of the configuration again. But if you want to remove configuration file along with package, apt get remove minus minus package. So removing a package doesn't remove its configuration file. To remove configuration file along with it, append with purge option. Use command download to download a package without installing it. So if you are download the package, just get apt-get download Python. So if you want to get into the source code of any package, because we are using Linux distribution, everything is open source over here, we can view source code packages of any package. So in that scenario, we can use apt-get source Python. So it will unpack the source code of the Python. So to check for the dependencies, we can use command apt-get check. So if we have to check the dependencies of Python packages, apt-get check Python. To install build dependencies, use build dep options. So it is there that whenever you are building your product or any software where there are many build dependencies of it. To get that, apt-get build up Python. So let's get into the demo of apt. So the first thing is apt cache show package SSH. So let's run it our own system. Apt cache show package. Let us go for OpenSSH. So it says there is no OpenSSH. Now we have installed Python. Now it is showing all the packages of the Python, a long list. So what are the packages which it has installed? It has installed any JSON that might be used for the JSON conversion from dictionary to JSON in Python. Mod Python, ModWSGI. ModWSGI is usually utilized for web servers. If you are hosting your Python packages online, ModWSGI, Mod Python are being used. So it lists all the packages which are installed along with the Python package. So rather than showing show package, it is showing package names. And these are default commands. If I'm writing package and using tab, it will be giving me package names by default. So these are the package names which are installed along with Python. So Python RPM is there, CryptoDoc is there, HTTP library is there, feed parser is there. So there are many packages like that. We have already seen how to install package. Now let's check how to apt-get remove ---- purge Python. So it is asking me for yes or no. Let's do no. And now what I will do is I'm just appending -y. Now it will not ask me for yes or no. By default, it has taken that, okay, I have given a confirmation for deletion of this package as I have supplied -y command. If you can see the last line, it says purging configuration files. So all the configuration files have been deleted. Now let's try the previous command, apt-cache package names. So you can see, even if I have not installed these packages, these are getting from the cache. It says that if you install Python, these are the packages which will be installed along with it. So you don't need to install any package to check what are the dependencies and what are the files which will be installed if I install Python. I'm going to install apt-get install Python 3. So you can see that I already have Python 3.6.5 in my machine. So it is not installing Python 3. And it also suggests that few of the packages are no more required. This Python 2.7, and if I run command apt auto remove, it will clean my disk space. It is suggesting that these packages are no more required. Python 2, Python 2.7 minimal, Python minimal, libpython standard library, because I already have Python 3.6.5 with 18.04. 2.7 is the older version of it, so I don't need these packages. Now I'm cleaning this off. Let's try apt-get update. So you can see it has gone to security.ubuntu.com, archive.ubuntu.com. These are the source list repositories which it has, and it is installing packages from there. Now it is updating itself. It is checking if any new version is there. It will be updating itself. Now it is reading the package list. Everything is done. Similarly, if I want to upgrade, it suggests me these many packages will be upgraded if I run this command. So you can see how Linux community is working. There's a huge community and it's working all day, and there are many updates coming every day. Now it has started upgrading it. So there are commands like apt-get check, apt-get install Python with ---- no upgrade.
So let's get with the interview questions here. The first question, the basic question would be, what is Linux? Okay. So as a layman, as an interviewer, if I ask this question, what is Linux? The first answer would be, it is an operating system. So before I get into Linux, first of all, let me explain you like what is an operating system. Every time you switch on your computer, you see a screen where you can perform different activities like read and write, or browse the internet, or watch a video. What is it that makes the computer hardware work like that? How does the processor on your computer knows that you're asking it to run a MP3 file? Well, it is the operating system or the kernel which does this work. A kernel is the program at the heart of the operating system that takes care of fundamental stuff like letting hardware communicate with software. So to work on your computer, you need an operating system. In fact, you're using one as you read this on your computer. Now, you may have used popular OSs like Windows, Apple OS X, but here we will learn what Linux is and what benefits it offers over other OS choices. So Linux is an operating system or a kernel which germinated as an idea in the mind of young and bright Linus Torvalds when he was a computer science student. Linus Torvalds is considered as father of Linux operating system. So when he was as a computer science student, he took a Linux kernel and he developed from the scratch. He used to work on Unix operating system, which in those days called as a proprietary software, and thought that it needed improvements. However, when his suggestions were rejected by the designers of Unix, he thought of launching an operating system which will be receptive to changes, modifications suggested by its users. The benefits of using Linux operating system. What are the main benefits and why it gained more popularity compared to other operating systems? The main benefits are it offers a free operating system. You do not have to shell hundreds of dollars to get the OS like Windows. Being open source in modify its source code. The Linux operating system now offers millions of programs, applications to choose from. Most of them are free. Now, once you have Linux installed, you no longer needed an antivirus because Linux is highly secure system. More so, there is a global development community constantly looking at ways to enhance its security. With each upgrade, the OS becomes more secure and robust. Linux is the OS of choice for server environments due to its stability and reliability. Mega companies like Amazon, Facebook, and Google use Linux for their servers. A Linux-based server could run non-stop without a reboot for years on end. Okay, this is all about Linux. So Linux is just an operating system or a kernel, okay, which has been developed from Unix operating system. So this is what we have discussed. And coming to the next question, how different is Linux when compared to Unix operating system? You might face different types of questions when you attend this type of interviews in Linux operating system. Like, what is the comparison? What is the differences did you find between like Linux and Unix operating system? As I said earlier, Linux is a Unix clone. But if you consider according to the POSIX standards, POSIX is nothing but a portable operating system interface. According to these standards, Linux can be considered as Unix. Exactly. To quote from official Linux kernel README file, Linux is a Unix clone written from the scratch by Linux Torvalds with assistance of hackers across the net. So I'll just take some strategies here in terms of cost, in terms of development and distribution, in terms of manufacturer, like what are the differences between Linux and Unix. In terms of cost, Linux can be freely distributed, downloaded freely, distributed through magazines, books, etc. There are priced versions of Linux also, but they are normally cheaper than Windows operating system. When you compare with Unix, in Unix we have different flavors of Unix, have different cost structures according to the vendors. In terms of development and distribution, Linux is developed by open source development, that is through sharing and collaboration of code and features through forums, and it is distributed by various vendors. When coming to Unix, Unix systems are divided into various other flavors, mostly developed by AT&T as well as various commercial vendors and non-profit organizations. In terms of manufacturer, Linux kernel is developed by the community by Linus Torvalds. Linus Torvalds will oversee the things. And when you talk about Unix, three biggest distributions are Solaris, which is now acquired by Oracle, AIX by IBM vendor, HPUX, it's by Hewlett Packard, and Apple makes OS X, which is also a Unix-based operating system. Okay. So I've just taken three aspects here, like cost, development and distribution, and manufacturer. Like this, we have many such differences between Linux and Unix operating system. So this is what we have discussed. Okay. Coming to the next question, like what is the importance of GNU project? GNU project was launched in September 1983 by Richard M. Stallman to create a complete operating system which is free software. The main intention of GNU project is to create an operating system which is completely open source, which is completely freely available for all public users. The main licenses of the GNU project are the GNU GPL, which is nothing but the general public licenses. The name of the GNU project is derived from the recursive acronym, which is nothing but GNU's not Unix. Okay, the full form of GNU, it's a recursive term. GNU's not Unix. Unix was a very popular operating system in the mid-80s. So Richard Stallman designed GNU to be mostly compatible with Unix operating system so that it would be convenient for people to migrate to GNU. So the GNU project was intended to create a Unix-like operating system, but it should be freely available for all the public users, and it should be an open source operating system. So this led to the birth of Linux operating system, okay, with the help of Linux kernel and the GNU utilities. And coming to the next question, the question is like, what is Linux kernel? Okay, so this is an important question, would be asked in different types of interviews, and most of the people will get confused in answering this question. What is Linux kernel? Let me explain you in a simpler way. With over 13 million lines of code, the Linux kernel is one of the largest open source projects in the world. But what is a kernel and what it is used for? A kernel is the lowest level of easily replaceable software that interfaces with the hardware in your computer. It is responsible for interfacing all of your applications that are running in user mode down to the physical hardware, and allowing the processes, which are known as the services, to get information from each other using inter-process communication. Technically speaking, a kernel is nothing but the core of any operating system, and it is responsible for translating the user commands into equivalent language understood by the computer hardware. Okay, so kernel, it is nothing but the heart of any operating system. It's a core of any operating system, which is responsible for translating the user commands into equivalent language understood by the computer hardware. Okay, so if you can see this, a pictorial representation on the left pane, okay, you see applications. On top of kernel, you see applications. And bottom of the kernel, you see the hardware devices. The hardware devices like CPU, memory, and the devices which are attached to the computer. Okay. So in order to interact with the kernel, okay, applications, you see on top of operating system, you have applications. So in order to interact with an operating system, applications need to have some kind of language, right? So kernel would be acting as a mediator between applications and hardware devices. It just translates the user's language to the machine language and machine's language to the user's language. It's a core. Kernel is nothing but the core, the heart of any operating system. And coming to the next question, what is a shell? And in shell, what is exactly called as a bash shell? Okay, first let me explain you what is exactly a shell. A shell is a user program or its environment provided for user interaction. A shell is a command language interpreter that executes commands read from the standard input device, which is called as a keyboard, or from a file. Shell is not part of system kernel, but uses system kernel to execute programs like creating files, creating directories, etc. Okay, so please remember, shell is exactly called as a user interface. In order to interact with operating system, we need one kind of interface, right? That interface is called as a shell. Okay, shell is a command language interpreter. Most of the people often confuse between interpreter and a compiler. Okay, please remember, interpreter is type of a mechanism that executes commands which are read from the standard input device or from a file. Okay, so when you talk about shell, in shell we have different types in Linux and Unix operating system. We have bash shell, we have single shell, we have corn shell, we have C shell, we have public domain corn shell. We have different types of shells used in Linux and Unix operating system. But bash is the default shell. Bash has been adopted as the default shell for most Linux systems. Okay, bash is a shell or a command language interpreter for the GNU operating systems. Once again, I'm using the term GNU. Okay, GNU operating systems like Linux. In most distributions of Linux operating system, bash is incorporated as the default shell. Okay, the name is an acronym for the born again shell. Bash stands for born again shell. Okay, it is named after a person called Stephen Born. Okay, he's the author for born again shell. Now, why bash has been incorporated as the default shell? Because in bash we have many such features like command aliasing, command completion by using the tab keys, and the command history also. Okay, like in order to execute the commands, like no need to remember all the commands in Linux operating system. Okay, with a lot of ease you can execute all these commands by the features of bash shell. Okay, command aliasing, command completion or file completion by using the tab keys, and the command history. Okay, in order to execute like previous commands, no need to type the commands again and again. You can recall those commands by using the up and down arrow keys. Using that, you can recall all those commands. Okay, if I show you practically one particular example, we have one command called clear in Linux. See, this is the terminal I'm using, the command line interface, the terminal where we can gain access to Linux operating system. I'm just giving one particular example, like why bash has been incorporated as a default shell. Okay, let's see what is exactly a command aliasing. I'm executing a command called clear, the command clear which is used to clear the screen. So every time you want to clear the screen, you run the command clear. Once you press enter, the screen will be cleared. Now instead, for this lengthy program, and what I'll do here, I'll just make an alias. C is equal to clear. Now once you press enter, for that particular command clear, I've been aliased to C. Now instead of running command clear, I can run the alias command called C. Once you press enter, the screen would be cleared. Like this, for any such programs or applications, if you want to do aliasing, this is possible with bash shell. Now these kind of features you cannot see in other shells. Okay, in other shells like C shell, conch shell, public domain conch shell, you don't see all these types of features in other shells. Okay, in Linux, if you want to see the types of shells which are supported, you can check this configuration file, the configuration file called /etc/shells. Okay, this is a configuration file where you can see the number of shells supported by Linux or Unix operating system. If you want to see what is the default shell, you can just recall the environment variable called shell. This will tell you what is the default shell used in the operating system. You see /bin/bash. Okay, so that is the importance of bash shell, and you must have got an idea like what is shell and what is the importance of bash shell. Okay, and coming to the next question, what are daemons? So this would be a tricky question asked in interviews, like what are daemons? If I put it in simpler format, a daemon, according to my readings, daemons are services that provide several functions that may not be available under the base operating system. Its main task is to listen for service requests and at the same time to act on these requests. After the service is done, it is then disconnected and waits for further request. A daemon process has no controlling terminal. It cannot open the terminal, for example, /dev/tty. If you do ps-ef and look at the pp-tty field, all daemons will have question mark for the tty terminal. Okay, I'll give one practical example here. If I run a command ps-ef, you see for most of the daemons, usually in Linux and Unix operating system, a daemon would end with D. Okay, you see, for example, let's take this particular daemon here, kthread D. Okay, at the end you see the character here D, which is nothing but a daemon. Okay, as I told you, a daemon process has no controlling terminal. If you check tty field here, for this particular daemon, you see a question mark. Okay, a daemon process is essentially a program that runs in the background and is usually started when the operating system starts up. Okay, if you want me to take one more example, a typical daemon process in a mail daemon that runs in the background, checking to see if you have received a new mail. When you do, it notifies you. Okay, so most daemons tend to last a long time, be owned by root or do something useful, but this is a very tricky question. Okay, what is the difference between a daemon and a process? Okay, so please don't get confused between this. A daemon is a service that provides several functions that may not be available under the base operating system. Okay, the main advantage, the main task is to listen for service requests, and at the same time it will be act on these requests. So that is about the daemons. Okay, one good example, you can always run ps-ef and you check all the daemons in the tty field, you see the question mark. That means we have not initiated this system. The operating system has initiated all these daemons. Okay, and coming to the next question, what is a lilo? A lilo is a Linux loader. It's a bootloader for Linux operating system. It is used to load Linux into the memory and start the operating system. Lilo can be configured to boot other operating systems as well. Lilo is customizable, which means that if the default configuration is not correct, it can be changed. The main configuration file for Lilo would be /etc/lilo.conf. Okay. As I said, Lilo stands for Linux loader, which is just a bootstrap program. Lilo is the code snippet which loads PC BIOS into the main memory at the time of starting the computer system. Okay. And the main task it handles is locating Linux kernel, identifying other supporting programs and loading them into the memory, and starting the kernel. Okay. So Lilo is not used nowadays. The default bootloader for Linux operating system is now Grub, which is called a GRAD unified bootloader. Okay. When you talk about the latest version of Linux operating system, it has been replaced with Grub 2. Okay. Some more features has been added in Grub, and they have released the new version that is called Grub 2. Okay. So this is all about Lilo. It is just a Linux loader. It is called as a bootstrap program. It's a bootloader which loads Linux operating system into the main memory. Coming to the next question, what are the advantages of Linux being open source? Okay. So we have been discussed in the earlier questions also the advantages of open source operating system. Linux was one of the first open source technologies, but many programmers have contributed and added software that's completely open source for any user. This means that you can download the source code and change it in any way you like. Some developers have restrictions on how you can distribute the code. For instance, some developers allow you to change the code, but you cannot distribute it for money. One main advantage of open source technologies such as Linux is a wide range of options available to users and the increased security. With Linux being open source, several distributions are available to the end user. For example, distributions such as Debian, Fedora, Ubuntu, and Mint are just a few of the distributions available to end users. And these distributions are completely free to download. Security is the other main advantage. Several white hat hackers have contributed to the overall security of Linux, and by making the source available to anyone, security experts can help identify any main security flaws in the operating system. Coming to the next question, like what are the basic components of Linux operating system? Okay, this is a general question which would be asked in the interviews. Linux operating system has primarily three components. What we have discussed already is kernel. A kernel is the core part of Linux, which is responsible for all major activities of this operating system. It consists of various modules and it interacts directly with the underlying hardware. Kernel provides the required abstraction to hide low-level hardware details to system or application programs. Okay, we have already discussed what is kernel. Next comes the second part is system library and system utility. Okay, system libraries are special functions or programs using which application programs or system utilities accesses kernel features. These libraries implements most of the functionalities of the operating system and do not require kernel modules code access rights. Like when you compare with Windows, in Windows we have .dll, which is nothing but dynamic link libraries. In Linux we have all the libraries which are there to read the file, write the file, all this coding part. Okay, implementation of the most of the functionalities will be there in the /usr/lib directory or /lib directory. Okay, and coming to the next question, how to check memory stats and CPU stats as a Linux admin. Okay, so in interviews, as I said earlier, the questions would be always in tricky format. Like you can expect questions in theoretical or you can expect questions in practical also. So you should be well advanced, you should be well prepared for the interview in the practical part also. So according to this question, being a Linux administrator, how you can check the memory stats and the CPU stats. So there are various commands in Linux here. One such command would be free. If you want to check memory statistics, you can run the command called free-m if you want to see the size in megabytes, or free-g if you want to see the size in megabytes. And if you want to see the virtual memory statistics, you have a command called vmstat. Linux vmstat command used to display statistics of a virtual memory. You can also see the kernel threads, the disks, system processes, IO blocks, interrupts, CPU activity, and much more. Okay, let me explain you this practically here. As I said, if you want to see the memory statistics, you can run the command called free-m. According to my system, I just got approximately some 10 GB of RAM, because by default I'm seeing in megabytes here 9,838 MB, out of which 651 is used, 8,714 is free. Or if you want to see that in gigabytes, you can run the command free-g if you want to see that in gigabytes. And when you talk about virtual memory statistics, you have a command called vmstat-a. Okay, so in this example, there are 6 columns here. The significance of the columns are explained, okay, in details here. As you can see, the first is the processes, the memory, swap, IO, system, and CPU. Okay, you can just find out with the vmstat-a command. You can also check the dynamic activity of your system. Like for example, you see I'm running the command here, vmstat2 space 6. With this command, vmstat execute every 2 seconds and stops automatically after executing 6 intervals. See this practically? See the interval here, okay? Interval is every 2 seconds and it will stop automatically after 6 intervals here. You can monitor like this, virtual memory statistics. Okay, if you want to see along with the time format here, you run the command vmstat-t, okay, 1,5 for example. Once you press enter, you can see along with the time format. Okay, so like this, we have many such options in vmstat. Based on the requirement, based on the performance and monitoring, you can execute those. And coming to the CPU, you have a command called SAR, the System Activity Report. Okay, with SAR-u, you can display the CPU usage. See, exactly, you can see the CPU usage. Okay, SAR-u displays the CPU usage for the current day that was collected until that point. Okay, if you want to see the real-time CPU usage, it's the same like vmstat, SAR-u 1 space 3. Okay, every 1 second, but 3 intervals here, you can see. Okay, SAR is very important command. It is used by every administrator to monitor the day-to-day activity. Okay, in SAR also we have many such arguments here. If you want me to discuss more, SAR-r to see the memory free and used, I'll give 1,3. You can also see with the SAR. You see the KB memory free, KB memory used, and memory used in percentage. You can see all that with the SAR command also. Okay, this is all about the system monitoring and the performance. So coming to the slide, so these are some programs we have just given in the slide here. We have discussed about the free vmstat to see the virtual memory statistics. And when you talk about CPU statistics, you can always use the program SAR, which is nothing but System Activity Report. So I just gave you some basic examples, but if you dig more into these commands, you have many such options. Okay, and the frequently asked questions in interviews would be how to reduce or shrink the size of an LVM partition. This is a frequently asked question in interview. See, the main advantage, if you just compare between a partition and a logical volume, the storage management can be created. Like whenever you want to create a partition, partitions can be created by using a tool called fdisk. But if you create a partition using fdisk, it is the fixed partition size. Later, it is not possible for us to modify or resize or shrink the partition size. That flexibility is not available using fdisk partitioning tools. Now, using advanced partitioning tool like LVM, which is called as a logical volume manager, we have a flexibility of either resizing a logical volume or reducing or shrinking the size of a logical volume. So let's see practically how you can do that in Linux operating system. I'm talking about advanced partitioning tool called LVM, which is nothing but the logical volume manager. Okay, so I've already created a logical volume manager here. As you can see with the command df-h capital T, you can see, for example, there is a logical volume here. The logical volume is Zoom Linux, and the type of the file system is ext4. The size is 4.8 GB, and currently this logical volume is mounted on the mount point called /lvm. So now I got a requirement of reducing this logical volume size. Okay, in other file systems, I'm running out of space. I would like to reduce this logical volume, and I want to increase the logical volume for other file systems. So let's see how exactly we can do that. So let me take one example here. There is a logical volume which is of 5 GB currently. I would like to reduce to 3 GB now. Okay, so that 2 GB I can accommodate to other file systems. The first thing is online shrinking is not possible. So first you need to unmount a logical volume. The command is umount and specify either the device name or the mount point. And then you can check whether you have any problem with this particular file system. You run the command e2fsck-f and specify the device name. Okay, so this is must and should. Before you reduce the logical volume, you just need to scan your file system. Okay, e2fsck is the command to check the particular file system whether you have any problems or not. Now once you press enter, so exactly you should find this. Okay, so we have no problems with this particular file system. Now we can reduce by using the command resize to fs, specify the logical volume name. I would like to reduce from 5 GB to 3 GB. The current size is 5 GB. I would like to reduce to 3 GB, and the remaining 2 GB I would like to accommodate to other file systems. Enter. Now you see the logical volume size has been reduced. Okay, so now we can run the command lv reduce -L 3 GB and specify your logical volume name. Now once you press enter, it will be reduced to 3 GB now from 5 GB to 3 GB. As you can see some information here, and then you can mount your logical volume to the mount point called LVM. Now you can see the logical volume size. Now it has been reduced from 5 GB to 3 GB. Okay, this is how you can reduce or you can shrink the size of a logical volume. Okay, so this flexibility is not available in fixed disk partitions. Once you create partition, that's it. Now you don't have a flexibility of modifying the partition size or shrinking the partition size. So this is possible only by using advanced partitioning tool called LVM, which is nothing but the logical volume manager. So let's get back to the slides here. So we were discussing about like how to reduce or shrink the size of a LVM partition or a logical volume. It's a 5-step process. First you have to unmount, run fsck, run the resize to fs to 3 GB or whatever required size you want, and then you run the command lv reduce to reduce the logical volume. Then you can mount that particular file system. Okay, the next question being explain the functionality of a root user. Okay, so in computing world, the super user is a special user account used for system administration. Depending on the operating system, the actual name of this account might be root, or if we talk about Windows, we call as an administrator or admin or supervisor. In Unix-like computer operating system, root is the conventional name of the user who has all the rights or permissions to all the files and programs in all modes. Okay, the root user can do many things which an ordinary user cannot, such as changing the ownerships of files, binding to network ports numbered below 1024. So root is the default account every time Linux is installed. So there comes your question again. What is CLI and what is GUI? Okay, CLI is nothing but the command line interface, is a console or text-based representation in which the user types the commands to operate the software or devices. The main advantage of CLI is multiple steps can be executed by specifying a single command, which is not possible in graphical mode. Okay, so a GUI, which is nothing but the graphical user interface is a graphical representation in which the users can interact with software or devices through graphical icons. Okay, simple definition. What is CLI and what is GUI? So how can you find out how much memory used in Linux operating system? It's again a same question here. So how exactly you can find out? There are many such programs here. The command would be free. Okay, the free command is the most simple and easy to use command to check memory usage on Linux operating system. So here is an example, free-n or free-g. Or you can also cat the contents of /proc/meminfo. This will also give you the complete information about your memory. You can see here the total memory, okay, memory in free and memory available, and you see the used and everything here. You can use this command also. You can just cat the contents of /proc/meminfo. Or better, the simple command would be free-g. What is swap space and what is the typical size for a swap partition under Linux operating system? So this is also one of the most frequently asked questions in interviews. So what is a swap space? Swap space in Linux is used when the amount of physical RAM, physical memory, which is also called as RAM, okay, is full. If the system needs more memory resources and the RAM is full, inactive pages in memory are moved to the swap space. While swap space can help machines with a small amount of RAM, it should not be considered as a replacement for more RAM. Okay, so people often get confused between main memory and swap memory. Okay, so if the CPU doesn't find free space in the physical RAM, so what CPU does is it just moves all inactive processes, all inactive pages from the main memory to the swap space which is created onto the disk, okay, to ensure it improves your system performance. Okay, so the preferred size for swap partition is twice the amount of physical memory, okay, amount of physical memory available on the system. If this is not possible, then the minimum size should be the same as the amount of memory installed. Okay, swap is used in normally desktops and laptops, okay, not in servers, because in servers we have equipped with more RAM. We have 32 GB, 64 GB, 128 GB. On those systems, there is no need to create a swap space. Okay, swap space only for low-end machines where we don't have enough RAM available. Okay, so swap is just to improve the performance of the computer, nothing more. And how do you access partitions under Linux? What is the naming convention for devices in Linux operating system? Okay, as you can see here, I'm running the program fdisk-l, and you see the first device. I got two drives connected to my Linux system. The first drive is /dev/sda, and the second drive is /dev/sdb. See the naming conventions here. The conventions used for SCSI drives. In case you have IDE hard drives, the first convention would be /dev/hda, hdb, something like that. If you got SCSI drives or SAS drives, the naming conventions would be SDA and SDB. And under this first hard drive here, if you see, you have the partition starting from SDA1 to SDA13. The first partition /dev/SDA1 and the second partition SDA2, like that. Okay, so these are the naming conventions used for your storage devices. And this is how exactly you can access partitions under Linux operating system. Okay, you see here IDE hard drive starts with H. In case you got SAS and SCSI, starts with S, SDA, SDB, go on. How are hard drives and floppy drives referred in Linux? Just now I told you, right? SDA, SDB, and for floppy drives it would be FD0, FD1. Nowadays nobody accessing floppy drives, but it would be a question in interviews. How floppy drives would be referred in Linux? /dev/fd0 /dev/fd1 based on the number of connections you have in your system. In case of hard drives, HDA, HDB. In case of IDE, if we have SCSI or SAS drives, SDA, SDB, something like that. Okay, these are the naming conventions used for floppy drives and hard drives. Similarly, in Linux, how are names assigned to different serial ports, what we also called as communication ports. The communication ports are identified as /dev/tt5s0 to tt5s1. You see practically here, ls-l/dev/tt5s*. You see here the communication ports. Okay, tt5s0, tt5s1. Okay, what we normally called as communication ports in Windows, communication 1, communication 2, like that. Okay, coming to the next question, asking about printer ports. How exactly you can identify the printer ports in Linux? Same thing, /dev/lp*, lp0, lp1, lp2. These are the names to use for printer ports. Okay, and the very basic question asked in interviews is, what are the kind of permissions available in Linux? Okay, what are the basic file permissions or the directory permissions available in Linux? So there are basically 3 levels of file and directory permissions in Linux. One is read. Read, like users only read the files or list the directory contents. And the second permission would be write. As the name suggests, users can write information to the file or create files inside the directories of a subdirectory. And the third permission would be execute. The users can run the file or look up a specific file within a directory. Okay, so besides these, you can have a combination of all these 3 levels of permissions, and 2 of them or 1 of them some combinations, read, write, execute, or read, write, or read, execute. Based on the requirement, as an administrator, I can change permissions. Okay, basically there are 3 permissions. The 3 permissions what we see here, that is read, write, and execute. Okay, coming to the next question, like how do you change permissions under Linux? So there is a command called chmod. Chmod is a command to change permissions for files and directories. And the permissions can be changed in 2 formats. One is symbolic mode, another one would be absolute mode. Symbolic mode is nothing but using numbers, and absolute mode is nothing but like using characters. Okay, like RWX or 755 or 644. With the help of chmod, you can change permissions. Okay, in order to change ownerships, you have a command like chown and chgrp in order to change ownerships for files and directories. Okay, see here, the command chmod is to change permissions, and if you would like to change the ownerships, you can use the command chown and chgrp. Okay, on the left pane you can see some representation here, user, groups, others, and the permissions are read, write, and execute. Okay, plus is to add permission, minus is to revoke permission, and is equal to override the existing permissions. Okay, the permissions can be changed in 2 different modes, symbolic mode and absolute mode. Symbolic using like characters, RWX. Absolute is using numbers. Okay, combination of numbers. The read value is 4, write value is 2, execute value is 1. You can either use characters or you can use numbers. chmod 700. What is 7? Read, write, execute. Applicable for owner. 0 means none permissions, applicable for group. 0, again none, and this is applicable for others. Okay, and coming to the next question, what are symbolic links? Very interesting question. Okay, symbolic links. So in Linux, basically we have 2 types of links. One is symbolic link, which is also called as the soft link. So symbolic link you can always compare. If you take an example, like in Windows we have shortcuts. Okay, we always create a desktop shortcuts. Now instead of going to the lengthy part or navigating into directories and directories, we can better create a shortcut on the desktop. Okay, for easy accessing and easy way of interacting with the operating system. Similarly, in Linux, it is called as a symbolic links or soft links. So this is one special kind of file that points to another file. Like I've compared with Windows, right? We have shortcuts. But please remember, symbolic link does not contain the data. Okay, symbolic link will not have the data. All the data we have in the target file, but not in the shortcut. Okay, and what are the benefits of using symbolic link? It just allows instant access. easy of access of application or a program, okay, without having to navigate to multiple directories here. Let me show you one practical example here. For example, I just want to see the configuration file of my LAN card, network interface card. The command would be cat/etc/sysconfig network-scripts, and the configuration file would be starting like this. This is my configuration file for my LAN card, ENP0S3. See the path here, etc sysconfig network-scripts. Under this directory, we have a file called ifcfg-enp0s3. Now instead, what I'll do here, I'll create a symbolic link. See, ln-s is the command. ln stands for link. Now what type of link I'm creating here? I'm creating a symbolic link. The path would be etc sysconfig network-scripts ifcfg-enp0s3. For this particular file, I'm creating a shortcut under my root directory with the name called ifcfg. Enter. The link has been established. Now, instead of viewing the LAN information, instead of going to this lengthy path, better I can read from the shortcut. Now, which one is easy to access? Either this one or from the shortcut. I know it is from the shortcut. See the properties here, ls-l/ifcfg, because this is exactly pointing to the original file, the target file. This is a link file, the symbolic link file, which is pointing to the target file. Now, instead of using this lengthy part here, I can better use my shortcut. Okay, so these are called symbolic links. Please remember, symbolic link does not contain the data. All the data we have in the target file. We don't have anything over here. Okay, what are the qualities of symbolic link? Now, both the files will have different inode numbers. We'll discuss about inodes. Both files, the source file and the target file, will have different inode numbers, will have different permissions, and the different size also. Okay, soft link will always have different name. Same content, both will be having same content, but the different name. Okay, and remember, soft links can be created only for files and directories. When you compare with hard link can be created only for files, but not for directories. But soft links can be created for files and directories. And soft link can cross the file systems also. You can establish a link between file systems, whereas hard link, you cannot span across file systems. Okay, I hope you got me about symbolic links here. See the qualities of soft links, what we have discussed. Okay, both files will have different inode numbers, different permissions, different size, but the same content, but with a different name. Okay, what are hard links? Now, in computing, a hard link is a directory entry that associates a name with a file on a file system. All directory-based file systems must have at least one hard link, giving the original file for each directory. Okay, the hard link is usually only used in the file system that allows more than one hard link for the same file. Okay, hard links can be created only for files but not for directories, and hard link you cannot span across partitions. It should be created within the file system. Okay, so these are some of the differences between the symbolic links and hard links here. And coming to the next question, like what is the maximum length of a file name under Linux? This is also one of the important question which is frequently asked in Linux interviews. Linux has the maximum file length of 255 characters. Okay, for most file systems like ext3, ext4, in those file systems you can have a file up to length of 255 characters. Okay, and the maximum path of 4096 characters. Okay, what we have discussed here, the maximum path you can have up to 4096 characters, and one particular file name you can have up to 255 characters. Okay, coming to the next question, which type of files are prefixed with a dot? So generally in Linux and Unix operating system, if any objects starts with dot or prefixed with dot, those are called hidden files. I'm under super user home directory. If I want to see all the files here, you can run a command ls-a, including all the files. You see one particular file prefixed with the dot. So this is exactly a hidden file. This is a regular file which is not starting with dot, and this is a file which is prefixed with dot. This is the hidden file. Okay, and you see a directory also which is prefixed with dot, and you see the regular directory. Public is the regular directory, dot cache is the hidden directory. So these files can be sometimes called as the configuration files also, which holds some important data. If you see one example here, cat bash rc, some aliases has been mentioned here for that particular environment, right? So mostly in Linux and Unix operating system, if any objects begins with dot, those are called hidden files and hidden directories. Coming to the next question, like what is a virtual desktop? Virtual desktop, like whenever a user's desktop environment, when you talk about user's desktop environment, like icons, wallpapers, windows, like folders, toolbars, okay, is stored in a remote server rather than on a local PC, then it's exactly called as a virtual desktop, okay? The desktop virtualization software separates the physical machine from the software and presents an isolated operating system for users. Desktop virtualization tools include like Microsoft Virtual PC, VMware Workstation, and Parallel Desktop for Mac operating system. The main benefits of desktop virtualization, it just includes like cost savings because resources can be shared and allocated as a needed basis, and more efficient use of resources and energy, improved data integrity because backup is centralized, and centralized administration. Okay, this is about the virtual desktop. What we have discussed, the benefits of virtual desktops. Okay, and what does a nameless empty directory represents? Empty directory, as you know, empty directory name serves as a nameless base for the Linux file system. This serves as a attachment for other directories, files, drives, and devices. Okay, empty directory. How can you create folders and files using the terminal? So in Linux operating system, if you want to create a directory, you can use the command mkdir. And to create files, we have many such programs. For example, like vi cat command, or you can use graphical based editors like gedit, nedit, pico, nano. You have many such programs to create files. Okay. You even have line editors, screen-based editors, graphical-based editors to create files in Linux and Unix operating system. Okay, but if you want to create a directory, you want to create a folder, use the command mkdir. Okay, and next question would be, what are the different ways to view the contents of a file? Okay, to view the contents of a file, once again, we have many such programs here. We have many such inbuilt Linux programs. You can either use graphical-based editors or text-based editors. Something like cat, vi, vim, gedit, you have pico, nano, you have many such programs. Okay, what are environment variables? One important and interesting question. What are environment variables? Environment variables are global settings that control the behavior of a shell. Okay, software packages installed in Linux and other processors. The path where the various softwares are installed will be stored as a environment variables. Environment variables are used to pass information into processes that are spawned from the shell. Shell variables and variables that are contained exclusively within the shell in which they were set or defined. While interacting with your server through a shell session, there are many pieces of information that your shell compiles to determine its behavior and access to resources. Some examples, if you want to see, in environment variables also we have different types. We have system variables and we have user defined variables. In the case if we want to see the system variables, you can run the command env. Env is the command to display all the environment variables which are set by default with the operating system. Okay, one good example of an environment variable would be path. Okay, this is a system variable which has the information about the path of all your binaries, all your executables. Okay, if you take one more example, you see the environment variable called home. What is the super user home directory, which is /root. Okay, these are some examples here. Environment variables, okay, system variables and user defined variables. What is the functionality of a tab key in CLI? We were discussing about the features of bash shell, right? I was talking about command aliasing, command completion by using tab keys, and command history. Let me show you practically here. In the current working directory called /root, I have a file called anacondacase.cfg. Let's take one example here. There is a file called anacondacase.cfg. If I want to see the contents of this file, I can run a program called less or more or cat. You can do anything here. But I have to type the complete file name, case.cfg. Rather, what I will do here, I'll simply type few letters. I'll use the tab key here. Automatically, the file name would be completed. See, cat anaconda case.cfg. I'm not typing the complete file name. I'm just using a few letters and then I'm using the tab keys. Enter to see the contents of this particular file. Similarly, there are many programs in Linux starts with the character C. I'll type C here. I'll use the tab key. I can see with the C letter, I have 162 possibilities. That means I have 162 programs here. You see one such program called cat. If you want to see CA, use the tab key here. With the CA, we have this many possibilities here. One good example is cat. One good example would be calendar. Okay, so these are the features of the bash shell. Okay, to complete a command or to complete a file name or the directory name. What is redirection in Linux? This is also one of the frequently asked questions in Linux here. So what is exactly a redirection? So in Linux, redirection is used to pass the output of one operation as input to another operation in the same command. If you see one example here, as an administrator, I would like to find out like the users who logged in with my operating system, who currently using my operating system. I can run the command called W. With the W, I can have all this information. Okay. Since when my PC is up and running, okay, for how long my PC is up and running, how many users are connected, and what is the load average of my computer. And you see the remaining information here, the users, the terminal they logged in, from which system they logged in, you see the login time, you see the idle, the JCPU, PCPU, and what exactly they're doing, what commands they're executing. Okay, I just want to send this report to one of my lead manager so that he can have this information here, W, and I would like to save this particular information in one particular file. So this is exactly called as a redirection. Okay, so redirection is nothing but which is used to pass the output of W command. Okay, output of one operation will be the input for another operation. Okay, W will display all this information and this will pass to this particular file. See, cat log, all this information has been passed here. This is exactly called as a redirector, the greater than symbol. Okay, it is called as a redirector, the redirector symbol, the greater than symbol. Okay, they give one more examples here. The cat files, file 1, file 2, the contents of file 1, file 2 will be in file 3. Okay, if file 3 already exists, the file 3 would be overwritten. And if you don't want to overwritten, if you want to append, you use double redirecting too. Okay, and what is grep? So this command is used for searching for a particular string, or you can also call it as a word, searching for a particular word in a text file. Okay, it also supports pattern-based searching. The pattern-based searching is done by including options and parameters in the command. Okay, one such example is the command is grep. I have one file here, the file called testing. In this particular file, I have some words and characters and numbers here. I would like to grep this word. The command is grep the word you want to search for from the file called testing. See, grep the string or the word you want to search for from the file called testing here. Okay, if you want to see with the line numbers, you can pass an argument called -n. At line number 17, I have the word called SD. If you want to see the count of the word, you can use an argument called -c. I just have only one word called SD in the file called testing, the count. Like this, we have many such arguments in grep. Okay, the pattern-based searching is also possible in grep command. And coming to the next question, like how to terminate on ongoing process in Linux here. So in Linux, every process in Linux operating system is identified by a Unix process, which is called as a PID number. Okay, PID is nothing but the process ID. To terminate any process, we can use the command kill. You can either use the process name or you can use the process ID. Okay, you see the command kill. And if you want to terminate all processes at once, you can use the command kill 0. Okay, it shouldn't be executed on production environments. Kill 0, not recommended command, but only for information's sake. And how to insert comments in command prompt. So this is a very basic question. Comments are inserted by using the hash symbol before the comment text. You see any such configuration file, for example, if you take /etc/grub.conf or /etc/profile, for example, okay, you see the comments here. The comments can be provided by using the hash symbols. So these are the commented lines, and these are called uncommented lines. So can you insert several commands in a single command line entry? If so, then how? It's a very good question. So this is also called as a command chaining. Like you can execute multiple commands one by one, okay, by using a semicolon. If I give you one practical example here, the first thing is I would like to create a directory called directory1, and then I want to go to this directory. Then under this directory, I would like to create all these files. So this is called command chaining. One after the other, the commands would be executed. The first command is to create a directory, and the second command to execute a directory. Under this directory, I'm creating all these files with the names called J, K, and L. Okay, this is exactly called the series of commands in a single entry. You go to this directory, see the files has been created here. Okay, write a command that will display all the txt files along with its permissions. Okay, write a command that will display all the txt files. Means we have to use the regular expressions, and the common extension we have to use is .txt. So I'll use the command ls-al start.txt. Okay, so in this particular directory, I don't have anything here with start.txt, but this would be the command. The command is ls-al start.txt. It would display all the files, including hidden files, with the properties. Okay, see here, I got geeta.txt, report.txt along with the properties here. And the next question, would you write a command that will look for files with .txt extension and has the occurrence of the string Edureka in it? Okay, so we have to use combination of commands here, and that combination would be, I'll give an example here of find / search from the complete directory here. I would like to search the txt files here. From the txt files, I would like to search for a word pattern called Edureka. Okay, the combination of commands here. First, it would find all the files which has the extension txt, and then using the advanced command called x-arguments, I'm running a command called grep-i. I'm searching for the word pattern called Edureka. Okay, find will list all the files with extension .txt, and grep is used to search for the string Edureka. This is how you can do it. Same thing. How to find the status of a process? If you want to find the status of a process in Linux operating system, you can run the command called ps-aux. Okay, so you see the status here, the status of a process. If it is S, it is interruptible sleep state. That means it is waiting for an event to complete. Okay, if you find D somewhere here, D, that is uninterruptible sleep state. Usually it is waiting for IO operation to complete. If it is R, that is a running state. If it is Z, that is nothing but the defunct process, which is also called as a zombie process. Okay, the process which is terminated but not reaped by its parent. If it is T, all of you, that is, it is a stopped state, either by a job control signal or anything it can be. Okay, you can also see some code meaning here. You have the greater than symbol, and you have N, you have L there. A greater than symbol is nothing but the process which is of high priority. You see here. Okay, interruptible sleep state which is of high priority. If it is N here, somewhere you see N here, N is nothing but the low priority. If it is L means the process where the pages has been logged into memory. Okay, like this you can find out the process states by using the command ps-aux, the status of a process. You should look into this column, the status of a process. And what is the command to calculate the size of a folder? This is also one of the important question, and you can find out with the command du, which is nothing but the directory usage, and with the arguments -sh of the directory boot. You see, for the directory boot, it is occupied 135 MB. Okay, the command du is to find out the directory usage of a particular directory. Okay, how to check the memory status of the system? It is a repeated question again. The command is free-m or free-g. Okay, same thing. And how to log in as root in Linux from the terminal? I've already logged in as a root here. Let's say, for example, I have a user called Edureka. This is a user logged in. With the user Edureka, I want to gain access to super user. Okay, I want to log in as root. Simple. I can run the command sudo su- and I think I don't have sudos configured here. I'll simply run the command su- and then I need to provide a super user password. Then I can log in as a root. See here, the prompt has been changed from the $sign to the hash prompt. $sign is the prompt provided for all users, and the hash prompt is the prompt only provided for super user. Okay, the command su stands for substitute user. With the user Edureka, I gained access to the operating system as root user. Okay, like this you can do the command su. And the next question is, how can you run a Linux program in the background simultaneously when you start your Linux server? This is a very, very important question, and this is frequently asked in interviews. And the command would be nohub. Okay, the command is nohub. By using the nohub command, the process will run in the background. Okay, any process which receives the nohub signal, okay, will be terminated when you log out the program. Okay, until then, the process would be running in the background all the time. Okay, please remember the command would be nohub. Okay, by default, it just places the process in the background. Which daemon tracks events on your computer, events on a Linux system? Okay, we have the daemons like syslog-d, we have daemons like rsyslog. We have so many tracking events in Linux and Unix operating system. Okay, the answer should be syslog-d or rsyslog. Okay, so what is partial backup? So partial backup is nothing but a type of backup where the complete operating system is not taken as a backup. Okay, only certain files, certain folders have been backed up, but not the complete file system. That is exactly called as a partial backup. Okay, so when you select only some portion of a directory, okay, in a single partition, that is exactly called as a partial backup. Partial backup is not the complete backup, only certain files and folders have been backed up. Okay, so in Linux, we have many such backup programs like tar, cpio, dump, restore. Okay, using this, you can take a backup, either complete file system backup or the selected files and folders based on the requirement. And next question would be inode, very, very important one. Inode is nothing but the contents of any file will be stored in data blocks, whereas information about that file will be stored in inode. So when we talk about data, data has two parts. The contents. The contents will be stored in the data blocks, and information about the file, what we called as metadata, that metadata will be there in the inode. Okay, so information, what type of information is stored in inode? Like the file size, the permissions, the user ownership, the group ownership, the link count, when exactly the file was last accessed or last modified. Okay, all that you can see in inode. So an inode number points to an inode table, which is a data structure that stores all that information, the size of the file, the device ID, the user ID, group ID, the file mode permissions, everything. Okay, so which command is used to set a processor intensive job to execute less CPU time? Very, very important question. And the answer would be the command nice and renice. Okay, these are the programs which are used to set a priority. Okay, you can change the process priority using nice and renice programs. So nice command will launch a process with an user-defined scheduling priority. Renice command will modify the scheduling priority of a running process. Okay, so the process scheduling priority ranges from -20 to 19. Keep this in mind. This is very important. Okay, the process scheduling priority range from -20 to 19. We also call this as a nice value. Okay, a nice value of -20 represents the highest priority, and the nice value of 19 represents the least priority of a process. Okay, if I show you one practical example here, let me just create one particular file, cat redirecting file 1. I'm creating a file. Okay, so in the backend, one process would be invoked because I'm creating a file here. Let me open another session here. Let me show you by just running the command ps-fl and the process name called cat. Okay, say this particular process by default, you see the nice value. The nice value is 0. Whenever you submit a process, by default, every process will have a nice value 0. Okay, see here. Similarly, if I submit a program with the less priority, for example, -10, okay, -10, cat redirecting file 1 here. Now you see the nice value. Let me open the this one. Let me recall the same command. Now you see the nice value for cat command. The nice value is 10. Okay, the nice value ranges from -20 to 19, -20 being the highest priority and 19 being the least priority. See, I launched a program with the nice value with the least value called 10. Okay, if you want to launch a program with the highest priority, I'll give -10. Okay, do not get confused here. It is not hyphen, it is -10. Now you see, now it is -10. Okay, that means this command requires more CPU time. Okay, similarly, unlike nice, if there is already a running process, that can be changed by using the command called renice. Okay, the command is renice -n, the priority you want. Okay, and you can give the process name or the process ID. You can do with the renice. Renice can be used if the program is already in used. Okay, very important programs. See here, the priority ranges from -20 to 19. -20 being the highest and 19 being the lowest priority. And the last question is like, what are shadow passwords and how they are enabled? So shadow passwords are given for better system security. Every user's passwords will be stored in /etc/password file. And by implementing shadow passwords, all passwords will be stored in encrypted format in a new file called /etc/shadow. Okay, the passwords in the original file will then be replaced with X. In multi-user environments, it is very important to use a shadow passwords. Okay, if I give one small example, like in Linux, we have two such database files here. One database file will have information about users, and other database file will have information about users' passwords /etc/shadow. Okay, we have two such database files here, which keeps information about users and users' passwords. Okay, so this is to improve the security. In earlier days, in earlier versions of Linux and Unix operating system, there used to be only one particular file which has everything, user and the user's file. See an example here, example called password convert cat /etc/password used to have everything like this in one particular file. You have users, the users' passwords and everything. But the problem is this particular file is readable by everyone. See here, /etc/password is owned by root. He got full permissions here. Even others got read permissions. Okay, which does not impose security on this particular file. Okay, so that is the reason there are two database files maintained. One is etc password and etc shadow files. Now you see the shadow file is only has read permissions for root. For others, you see we have none permissions. Okay, so this is how we have two database files here, etc password, which has information about users, and etc shadow, which has information about users' passwords. Okay. Not only passwords, you also have information about the password age also. For how long we can use this password, when password would be expired. All this information can be used in etc shadow file. Okay.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!